as Catholics, our faith is not just coming from revelation, but it's defended in a lot of ways by a philosophical framework.
What we're advocating for is a discipline that asks these very specific, okay, what do we mean by time? What do we mean by motion? What really do we mean by the fundamental constituents of physical things? That's not a question they ask.
Can we just say that time is tied to motion?
Apologetics and evangelization, you're apologizing, you're defending what, or you're evangelizing for the sake of what? Those are means towards a deeper vision of the truth and ultimately the source of that truth.
So, is Einstein right or is Aristotle right? Welcome to Think Catholic. My name is Austin Habash, your host. Today I'm joined by Dr. John Brungardt, Dr. Thomas McLaughlin, as we discuss the cosmos, and specifically rediscovering the cosmos. Because I think you and I, our society at large, have been sold a false bill of goods when it comes to our understanding of the universe. The first of which is termed scientism. The only things we can know to be true, or certainly true, must come to us from biology, chemistry, and physics. And any philosophical inquiry into these sciences, or philosophical inquiry at all, is at the best just a personal opinion, or at the worst, just a total waste of time. The second dogma, which we've been indoctrinated into, is materialism, and specifically an atomist materialism, which tells us that I really am just cells, and those cells are really just chemical compounds. Those chemical compounds are just atoms. Those atoms are just subatomic particles, and so on and so forth. So that there really is no essential difference between me and the table. The only difference is a difference of quantity and arrangement of some very small material things. The third dogma, which we have been schooled in, is a mechanistic worldview, which tells us that this world does not have goals, it does not pursue ends. So it's not the case that light takes the path of least time because it has a particular nature and a particular end encoded into that nature, but that light takes all paths, infinite paths, which then just collapse into the most efficient path. But why then this efficiency? And so we are looking for better answers to these most fundamental questions about our universe. And it is my hope that Dr. John Brungardt, Dr. Thomas McLaughlin will give us some of these better answers. And so I have so many questions, but before we begin, Dr. John Brungardt, Dr. Thomas McLaughlin, would you like to tell us a little bit about yourself, why these questions matter to you?
Sure. Thanks very much, Austin. There are a few reasons why questions like that matter to me. I was raised Catholic. I'm the oldest of 10. I was homeschooled. I went to a small college in California, Thomas Aquinas College. It's known as a great book school, but one of the things that we do there is that we study a lot of philosophy, a lot of Aristotle, a lot of St. Thomas, but there's also running alongside that a good bit of the early modern sciences, and those the three dogmas that you mentioned at the beginning. You can really, as a student, you can really see the roots of those in early modern science, and so that set up in my undergraduate soul this tension between Aristotle and Aquinas and perennial philosophy in general, and the competing philosophical views from early modern science. And so that led to further questions about how to work that out.
Dr. Thomas McLaughlin, you want to tell us a little bit about yourself?
Sure, thanks, Austin. So my parents are Catholic, and they raised me Catholic. I got interested in the sciences through the space program and through astronomy. So I'm old enough to remember the early Apollo missions. So you have to have this image of this little Catholic kid sitting in front of the TV around Christmas time watching Apollo 8 go behind the moon. It's the first mission where the astronauts actually went out that far out of Earth's orbit. They go behind the moon, we lose contact with them. They come back around, and you have this iconic picture of the Earth rising over the lunar surface. And then on Christmas Eve, the three astronauts take turns reading from Genesis 1. It's just incredible scene. At that time, a lot of the early unmanned missions were arriving at the planets. So we had the first scenes from the surface of Mars with a Viking mission, and then Pioneer and Voyager missions. They go out to Jupiter, out to Saturn, and then Voyager 2 continues out to Uranus and Neptune, and now they're exiting the solar system. That was almost revelatory. Nobody had seen some of the scenes that the spacecraft were showing. At the same time, the big telescopes at the big observatories at Palomar and elsewhere were producing these really high quality color pictures. I mean, that had really come of age. And so you're seeing these gorgeous pictures of galaxies and star clusters and nebula. It was really amazing. Also, just recently, the Big Bang cosmology, Big Bang theory, had kind of defeated its big opponent, the steady state theory. That had happened some years before, but it was still very much kind of in the air. Mm-hmm. So I just kind of fell in love with all this, and it's just a very evocative in terms of wonder, leads naturally to interest in the other sciences. And then astronomy and space sciences are really naturally philosophical. I mean, they really lead to or generate philosophical questions. So even by the time I got to college, I was already asking philosophical questions coming out of the sciences, and especially out of astronomy and cosmology. And to make a long story short, what I eventually found in the Catholic faith and in Aquinas' theology and philosophy in particular was a kind of lens or intelligible framework that situates the sciences and reveals a kind of further understanding of them and helps understand what they're saying. To make a long story short, that then develops over time, and I would say now that really, since the time of Copernicus, the general movement of science has shown us a universe that fits much better with the faith and much more with the kind of philosophical and theological thinking that one sees in, for the most part, Aquinas and to some extent the Aristotelian tradition as well.
Now, I'd like to ask why you two believe that these topics we're going to get into here are relevant for your everyday Catholic, your man walking down the street. And someone listening to this might wonder why I'm in this room. Why is the door-to-door evangelist here at this table? Why am I concerned about these questions? And you've already alluded to it, Dr. John Brungardt, that as Catholics, our faith is not just coming from revelation, but it's defended in a lot of ways by a philosophical framework. So when we talk about transubstantiation, when we're looking at the Eucharist, that does presuppose that substance, that form is a reality out in the world. So I see it from an apologetic standpoint. How can we defend the faith today, looking at contemporary science? But then also, when it comes to evangelization, I was at a clothing store the other day getting some of my measurements done to be a Dominican so they could put the robe together for August. So I'm at this tailor, and they asked me what podcast I'm doing here. And I could have led with, it's Think Catholic. Yeah, but when I talk about religion, a lot of times people, their faces glaze over, they're not super interested. So I started with, it's a science podcast. Yeah. And immediately everyone lit up. They were so excited. Cool. So if you can begin with science and then you can show the conclusions of the science that we see out in the world leads to God, soul, form, then I think it's an easier way to talk to people, have that discussion. What would you guys say is the relevance of these topics we're going to get into today to your everyday man and woman on the street?
The thing that jumps to my mind, Austin, is the sciences and studying the philosophy behind and really throughout the sciences. What they're trained on is the intelligibility of the universe. There's a seemingly inexhaustible realm of truth in the universe and how it's ordered and put together and designed. So not just for your everyday Catholic, but just your everyday person. I mean, the intelligibility of the universe, how our minds have been created, the intelligibility of the universe is really something that can measure us, it's something that can teach us. Mm-hmm. We tend to think of nature as something kind of alien and something we can manipulate and control, or something that's opposed to us. Why it's important to have a deeper philosophical and theological grasp and kind of insight into these kinds of topics, into the cosmos and how that can fit with the faith. it comes down to the truth that's in the universe, the intelligibility that's in the universe.
Okay. And maybe just for the sake of contemplating, as you were talking about with your story a little bit, just basking in it.
So not to, apologetics and evangelization are necessary. But it's you're apologizing, you're defending what, or you're evangelizing for the sake of what.
Mm-hmm.
And it's not, those are means towards a deeper vision of the truth and ultimately the source of that truth.
That's well said. And yourself, Dr. McLaughlin?
Yeah, I might add a couple of things to that. I think as a cultural phenomenon, we see space photography all over. It comes up. The amount of it in the culture is really quite extraordinary. That's a fairly new thing, new meaning several decades past, and it's everywhere. And even scientists note this. They're at MIT, they're at Caltech, and places like that, and or there are places that aren't real science centers, and what do they walk into in the dorm rooms? It's a picture of Jupiter or Saturn, and it's incredibly beautiful. Stunningly beautiful. The Hubble telescope, it just got incredibly beautiful shots. Some of these space missions that were orbiting Saturn, it's just, you could make a beautiful movie out of the whole thing. It's just so incredible. And that beauty is something evokes the transcendent. And I think so it naturally gives rise to a sense of wonder, and we question that and wonder about it. And then it also, in addition to beauty, you just go, wow, why is this? Why is the universe like this? Recently in the Artemis mission, the mission commander, when he got back to Earth and he's on the recovery ship, he's so blown away by what he saw, he asked to see a chaplain. And when the chaplain comes into the room and he has a cross on his lapel, he breaks down and starts in tears. I once gave a talk at a parish, and I was really surprised. I'm Big Bang Cosmology, and I was really surprised that there were a group of about 10 people who just wanted to keep talking afterwards. And the parochial vicar asked us to go, how about we all just go sit in this room and talk for an hour? We talked for an hour and a half, and the only reason it didn't go longer was I had to go pick up my kids. Okay,
that's a good reason.
And I asked the priest about this later, what's going on? And he said there's actually a really deep hunger in people to ask these questions and to be able to just talk about it with somebody and just to be able to ask what's on their mind. The heavens declare the glory of God. This is not a surprise. So, Kant, Plato, Aquinas, Scripture, they all see this really powerful sense in which we're moved by the natural world, but especially by the starry heavens.
So as we dive in, one of the first questions I have for us, we're talking about the cosmos as if we're talking about a whole, kind of like we would talk about a human person, we might talk about a society. So are we actually talking about a whole that has parts that are somehow related to one another in the universe? Or are we just using cosmos as a label for all movable material things that we happen to find down here?
So one of the really important discoveries of 20th century science, or first third of the 20th century, is the discovery or rediscovery of the universe as a kind of whole, unified whole of very different parts. And that is a very Aristotelian Thomistic kind of vision in which Thomism, you begin with the whole and then you move toward the parts, and then from the parts you go back again. So it's not sort of an approach where you micro-study the parts and then try to recover the whole, but it's a holistic approach. And so in the early 20th century, Einstein's general theory of relativity gives the first physical account of a non-contradictory system of gravitationally interacting objects. And it took a little bit of time to realize it also predicts that that system is going to be either expanding or contracting. And at the same time that's being figured out, you also have a kind of empirical discovery by Hubble that the galaxies are receding, and they're receding from us and receding from each other in a very ordered way. And so, and then that comes together in Father Georges Lemaitre, who is a Catholic priest, and he's working in both general relativity, he knows what the astronomers are doing. And so what you have is a kind of whole predicted by general relativity with a motion that's peculiar to it. The whole universe is expanding. Okay? And so now that presumes that you've got a kind of whole there that is highly integrated and shows these universal features.
So our marker here for wholeness is going to be motion. Is this one of our markers for saying that this is one universe? We have a unified motion across the universe. Is that how we're calling this one whole? Or are there other markers?
There are other markers as well, but that's a key one. And the other markers would be on the physics side. You increasingly have a movement toward, in the sciences, to unify the four fundamental forces. And then in the 80s, you get a standard model in which you have a unification of three of them, gravity being sort of the one that's not together yet. But then in the Big Bang, when you posit a kind of Big Bang, you've got general relativity coming together, and then you have to bring in quantum mechanics once you start talking about the very small. And then in astronomy, over the decades after that, you've got a kind of a structure that's discovered that is characteristic of this whole, and that structure has a history. It's changing over time. It has a history in which it's generated. You get a kind of structure, and then we can try to predict, okay, where is this going? How is this going to change? And you have key discoveries all throughout this. One of the important ones in the mid-60s, the discovery of something called the cosmic microwave background. So it's a kind of background electromagnetic energy that's pervasive everywhere. And so that's a part of an example of a structure that is part of the unity of the cosmos and also the way the various forces come together. But yes, it's this motion that is, I think, a key part of the initial discovery.
And I think it's important to really underline what Tom is saying about how the Big Bang theory, the Big Bang model, discovered the history of the cosmos. Because if you contrast that with the predecessor theory to the general theory of relativity, so a kind of Newtonian celestial mechanics, they didn't have built into that theory how time or space was an integral ingredient. It was just, time was just, it's the index, like here's when things are happening, and then the space is where things are happening. And so you had to, the astronomer Edward Harrison has a nice pair of papers on this, and it's also, when Tom had said the general theory of relativity was the first contradiction-free theory, I mean, he was alluding to some of these difficulties that, well, how is the matter in the universe initially distributed? Is it finite or infinite? And depending on assumptions you make about those things, how it's distributed, where it's distributed, its amount, you then can quickly get to scenarios where the universe, according to Newtonian celestial mechanics, doesn't have enough time to develop. Just before the general theory of relativity was discovered, in the 1800s, some geologists were realizing this, that their theories in geology were pointing out that the Earth is a lot older than what the astronomers could support. When you try to scale up, right, this Newtonian mechanics has been trained on the very local, and you try to scale it up to the whole, it turns out that you can't do it. You don't get a coherent picture of the whole.
Of the history of the universe. Yeah. And you're saying Einstein's theory allowed us to give a coherent account using Big Bang cosmology.
And you can put this in a really particular way. I mean, astronomers now say the universe is 13.8 billion years old. I mean, they have a number for its age. I mean, that is just really remarkable.
Pretty incredible.
And in general, in relativity, there's a dependence of time upon motion. That's very Aristotelian. It's very not Newtonian.
Do most people know that, though? Do they realize that to bring time as dependent upon motion is an Aristotelian thing, that it's not novel? And Einstein, do they realize that we're actually pulling from?
I would say no, most people don't realize that. And we're pulling from an Aristotelian idea in a particular way, that in the Aristotelian theory of motion, you have time as a measure of motion, but you also have time as a kind of feature or accident of motion. The reality of time only exists and it only unfolds because of the reality of motion. Whereas in the Newtonian, the classical Newtonian picture of space-time, time is just, I mean, you can think of it as an independent reality or an independent variable. It's not, it's only accidentally tied to
Actual
motion.
Moving things.
Yeah.
Wow. And so if cosmology has the cosmos as its object, what can we say about cosmology as a science and how it relates to the other disciplines? Is it just taking physics and throwing it into the very large, or is cosmology going to be more fundamental than physics? How is it interrelated with those other disciplines which we're familiar with?
In the early 1900s, cosmology, in the sense we use it today, was not accepted as a science. Around 1918, 1919, so you get Einstein developing the general theory of relativity. Pretty quickly after that, you get, say, Sir Arthur Eddington going down to the southern hemisphere and taking eclipse observations that help confirm Einstein's predictions about general relativity. You get Hubble's observations of galactic or extragalactic redshift, so that the universe is expanding. Mm-hmm. You get Lemaitre, but cosmology as a science, it wasn't accepted as a science. It was, pardon the pun, it was nebulous where it would fit in.
Well done.
So you actually have physicists or astronomers debating in the 20s and 30s, debating how you would begin or conduct cosmology as a science. Mm-hmm. So how does it differ from just astronomy with, now you're taking into account an older natural history? It's like, where's the causal account, or what laws are you dealing with? It's that picture of proposing not just digging into a natural history, but proposing causal explanations, developing a testable type of model, really a class of models that took a while to fit together. But that's, so cosmologists will say that, cosmology it fits with one of the archaeological sciences because it looks at really, really old starlight and very distant space dust and all. But I think we should consider it one of the natural sciences because it proposes causal explanations, even if it's not done yet.
Okay, there are two things I wanted to add to that, because I think one of the questions you asked is cosmology independent of physics and so forth.
Yeah.
That's a really hotly debated, a debated question.
Okay.
But what I would want to add is the expansion of the universe, okay, and according to the Hubble-Lemaitre law, that is not caused by any force known to the physicists, okay? It's not due to one of the four fundamental forces, okay?
So you can't build it on the elements of physics. It just doesn't fit right there.
Well, they're very closely related. That's what's so beautiful about the cosmology, is it integrates the physics and you, okay? The other thing is the role of chemistry. Is by the time that this early cosmology is being developed, the nuclear physics of fusion and the powerhouse, what powers stars, was becoming known. And something about the abundances of the various elements had become known. And basically, most of the elements are made inside of stars. But then you got to account for the helium and the hydrogen, and helium and hydrogen come out of mostly the immediate aftermath of the Big Bang and lithium. And what's interesting is that, so chemistry folds within Big Bang cosmology really beautifully in the way that it accounts and uses physics to account for the origin of the elements and the origin of chemistry and even of early minerals like diamond and things like that.
So we're talking about cosmology here. I want to go back to something we mentioned at the very beginning on scientism. So how the sciences play with one another, or how they collaborate with one another. So thinking back to what most people are taught in schools on scientism, we are taught to hold skeptical anything that smacks of philosophy. So if I can't see it in a microscope and then it doesn't come out of the math, I can't be certain it's true. What people don't realize is that the math doesn't interpret itself. And one of my favorite examples of this is Dr. Richard Feynman, Nobel Prize winner, I think in quantum electrodynamics, might be where he gets his prize. He has in one of his lectures at the University of Auckland, I think it's in New Zealand. He gives this example of the Mayans. And he said, we found 3 books from the Mayan civilization. You remember this story? This is like one of my favorite stories he tells. He says in one of these books, we found how the Mayans calculated the solar cycle and the cycle of Venus. And they found out for every 5 Venus cycles, you'll have 8 solar cycles, something like that. And then Feynman goes on to say, all right, imagine you pull aside this super priest who's able to do the math on this natural phenomena. And then you ask him why. Why is it 5 cycles every 8 cycles? What is he likely to say? Feynman says, well, maybe he'll say, because these are the lucky numbers and these are unlucky numbers, and you put them together, and that's why it has to be that you have 5 Venus cycles and 8 solar cycles, or because the Venus god is like this and the solar god is like that. And what that impressed on me is that the math never interprets itself. So you can do the calculations, but then you have to bring a philosophy to that mathematics. So when we're talking about a philosophy of nature, a general philosophy, I do think everyone out there does have to have answers before they come to the calculations on what space is, on what time is, on what motion is. So could we describe here for a moment, what do we mean by a philosophy of nature? Where does it fit in with the other disciplines?
I mean, I agree. When you come to a specific scientific investigation, you're assuming a lot of those answers. You have an implicit philosophical basis. You kind of alluded to scientism is in that strict form, right? In the typical form, it's self-refuting.
Mm-hmm.
You cannot, in fact, put the empirical method through the empirical method. You have to. You're making assumptions about how it helps you to determine the truth.
Mm-hmm.
And so one way to start thinking about what natural philosophy is to recognize that Newton would have called himself a natural philosopher. Right? The word scientist wasn't in English, at least wasn't invented until the 1830s. Newton or Kepler, Copernicus, Galileo, they were trained in this older tradition, and they would just think of themselves as natural philosophers. Natural philosophy and the philosophy of nature, when Aquinas talks about it, he puts it within a broader realm of different scientific disciplines. So ways of knowing reality that in different yet related ways, you can call them all sciences. So for example, he thinks sacred theology is a science, right? Its basis isn't reason. It's not things that we know through sense experience or reasoning about them, but its real, even though theology does involve those things, right? But its real basis is the supernatural act of faith in the articles of faith. But then within the realm of natural reason, Aquinas will, following Boethius or Aristotle before him, he'll distinguish between knowing things in a speculative way versus knowing things in a practical way. He'll distinguish logic as a kind of tool of those sciences, so knowing things in a rational way and knowing and reflecting on our own acts of reason. So natural philosophy really fits into that speculative part. Right? We're knowing reality just for the sake of knowing it. It does have connections later. It can have connections later to practical application. But the real impetus, the draw, is we want to know why all of these photographs from space are so amazing. I mean, what's making it do that? Why is it like that? So natural philosophy in Aquinas's organization fits into, well, it's not the most abstract approach to studying reality. So typically we think of that as metaphysics. It's something that's so abstract that its object of contemplation is, in a really true sense, free of the material, even if you can relate it back to the material world. And neither is natural philosophy abstract in the way that the mathematical sciences are, because the mathematical sciences, what we would usually call pure math, they don't have to worry about what their objects are made of or what their temperatures are, if they're going to break down in 5 years. The Pythagorean theorem will be true if you put it in it's copper or steel or paper, it doesn't matter.
Got it.
Whereas natural philosophy is concerned with, it still studies at this level of abstraction. It wants to know things universally, but it wants to know things universally that are in matter. How does the material cosmos work? The important thing about that is that's where our mind, the human mind, is naturally set up to start, right? We start with the sensible and the very material, and it's only later, as natural philosophy develops, that we start bringing in mathematical tools to help us. And it's only after reflection that we're able to relate natural philosophy to something like metaphysics.
So then is the term physics trying to say natural philosophy without implying a philosophical backdrop? Is it a narrowing? Trying to jettison
at least how it's used now, typically how it's used nowadays, because then you describe natural philosophy as philosophy of physics or philosophy of science, or sometimes you describe it as the metaphysics of physics, but those are contemporary terms. The older tradition, the scholastic tradition, wouldn't have used those terms. It's natural philosophy, and then it ramifies into more specific areas.
Sciences.
Yeah.
Could both of you speak to then what I was saying a moment ago about how you cannot do physics, biology, and chemistry without a philosophical framework? I mean, when you imagine you're not bringing philosophy into the lab, you're bringing in bad philosophy, but either way you do have to bring in a paradigm, a framework of the world.
The basic idea here is that natural philosophy is one discipline and it has parts. It has a very general part called general natural philosophy or general science of nature. And then has much more specific parts, which we call, using contemporary language, physics, chemistry, astronomy, biology, and the life sciences, geology, and the earth sciences. Okay. And what we're saying is that these specific sciences are not autonomous. They can't stand on their own. And you can see this immediately because of the use of mathematics.
Okay, across the board,
and the use of logic. But they're also going to make various sorts of philosophical assumptions as well. So when an evolutionary biologist tells you that living things have a function, but they don't have a purpose. I mean, he's invoking some sort of philosophical distinction, which
sounds a little foreign.
It sounds a little foreign, right? A little fishy. And similarly, when you are thinking about time, the example I gave earlier, you've got Aristotle, and time is dependent upon motion. For Newton, that's not the case. And then with Einstein, it is, and there are all sorts of issues involved in that. The sciences tend to draw on these larger natural philosophy issues. And if you imagine a paleontologist, and he's in a cave, and he's looking at cave art, and he's trying to describe early hominids or early Homo sapiens, but he's looking at art. Now, he's going to have to draw upon some sort of thinking to recognize this as art and to be able to give an account, or he's going to have assumptions about what art is and what that is going to entail about the kind of creature that is doing the cave paintings. One of my favorite examples is when Einstein is writing one of his famous papers. It's on quantum mechanics. It's the EPR paper, because he writes it with two junior colleagues. He formulates his argument in terms of realism and locality. So he's explicitly drawing upon philosophical notions of realism and philosophical notions of place and locality.
That's what locality means, natural place. That's what we're talking about.
Well, he's talking about really space and place relations there. Now, Einstein is the kind of mind who can explicitly draw upon philosophy and specify it to a very exact physical problem. I mean, and
That's great.
And so there are all sorts of philosophical and scientific debates going on around that paper. Now, it turns out, very interestingly, that Einstein seems to have been wrong, but where did he go wrong on which of the assumptions? Realism, locality, and so forth. And one of the prominent interpretations is it's on locality. So there you can actually see it working. You can see it working in evolution, especially if you're assuming that you can account for the entire origins of the human person in terms of evolution.
Via that process.
You're making assumptions there about the human person.
Have you seen a dichotomy? When I look out into our academic society, the ones who are publishing books, writing papers, it seems like you almost have the mathematicians over here, the mathematicians, the astronomers over here, the physicists over here, and then you have the philosophers over here. I mean, are you seeing that dichotomy in the people that you're speaking to? That they can do very advanced math, like the Mayan example, but maybe they're using an archaic philosophy?
Yeah, I think that's what troubles us, is that we come out of, or we're thinking in terms of a discipline that doesn't separate that. Well, the distinguishes in it within one discipline so that they belong together. Okay. But at the time of the scientific revolution, probably arguably focused on Galileo, you get this split between what we would now call philosophy and what we would now call science. So
it's rare to find a person that can appreciate both. Just speaking for myself, I'm more on the philosophy side, and I'm mostly self-taught in the sciences. I've taken science courses, but I don't have a PhD in one of the advanced sciences. But you find there are a number of prominent examples. So the cosmologist and mathematician George Ellis knows a good deal of philosophy. Carlo Rovelli, the Italian string theorist, he's an example of, here's someone to recognize this. No, you need both the inevitable philosophical background and kind of substructure and kind of philosophical articulation of the science. And he's written on that. Part of what makes that difficult is the sort of examples Tom was talking about with the cave art or Einstein specifying realism or locality.
Evolution.
Yeah, you're drawing from concepts that are very general. In order to make headway in the advanced sciences, you have to bring them to a level of specificity that there's tons of options. There's different ways you could specify something as general as motion, but it's holding that together, and then going back and forth. Well, here's the general understanding of motion that I have at first, and then I can specify it in this way, and specify it against what the world is actually doing. Right, so holding that whole thing together habitually, that's, to my mind, that's a way of saying you're doing natural philosophy. You're not just doing specialized science, you're seeing this bigger picture. So just that, Aristotle calls it the natural path. That's how the human mind naturally works. We start with this more general, like things are moving, we can define motion in general. But it's different if you get to Newton's first law of motion, or Kepler's 3 laws of planetary motion.
So there
Those
you're
are very
looking at very
examples.
specific kinds of motion. So DNA replication, plate tectonics, thermal heat transfer. You could talk about all the specific sciences, talk about motion, but they talk about it in very specific ways. So the question, well, what is motion? Just in general, what do you mean by motion? Okay, that's not a question they ask.
At the specific level.
At the specific level, because they're operating with living things or with earth sciences. So what you need is some discipline that can address that question at the very general kind of level, because it's going to be presupposed in some way. You're going to presuppose answers in the specific level, even if you don't consciously
or know you're doing philosophy.
Articulate that, right? Because it's going to be part of what you're doing in some kind of way. So what we're advocating for is a discipline that are part of a discipline that asks these very specific. Okay, what do we mean by time? What do we mean by motion? What really do we mean by the fundamental constituents of physical things. And we can point to atomism, for example, and say, wow, a lot of these scientists had been assuming something that looks very much like classical
Democritus,
atomism. Now, they didn't read Democritus, okay? That's not how they pick it up, but it's recognizable.
So we can the natural philosopher can keep people from repeating mistakes of old, paradigms of old. Like the contemporary atomist saying, no, look, Democritus tried this, and he found out you're going to lose truth, you're going to lose the qualities in the world, you're going to lose voluntariness.
It can help them see that what perhaps they're saying or their interpretation of the sciences is an interpretation that makes philosophical assumptions. It's not just the science.
Right.
And it helps explain some of the disagreements between scientists that are at a sort of very fundamental
level,
kind of level, but don't seem exactly scientific in the narrow kind of sense.
Great.
So I think that's a key distinction to what John and I are doing and how we're thinking. It's a distinction between a very general approach to nature that asks very general questions like what is place, okay? And if you're going to understand nature, you're going to have to be considering those kinds of questions because they're part of what's going on in the natural world. And if you don't like our answers, okay, are you at least committed to the question? Or are you just going to assume an answer?
Keep doing the math. Keep building the rocket ships. Don't worry about these more fundamental.
Well, then you're more of an engineer than a scientist.
Okay.
Right?
Well, another good distinction.
And I like engineers. It's not meant to
We
be
need
slam.
them. Yeah, we definitely need them. So I'd like to circle back to another one of these dogmas that our society has been indoctrinated into, and that was the materialist, specifically atomist paradigm, which gives priority to what is smaller, to the parts, as opposed to the whole. So as I said earlier, it's not that I'm a human being, one human being that has various faculties and powers within me, but I really am just cells, which are not cells, they're just atoms, which are just subatomic particles. And a couple quick problems with that. Dr. Ed Fazer does a good job of saying, we can't hold that's true in the scientist, because we do presume that the scientist is one subject which continues across when he makes the observations, to the hypothesis, to testing, to giving us the general theory. So we do hold, at least with the scientist himself, that he's not just atoms, but there's an enduring whole across all of those thoughts. And Fazer also does a great job of asking, if you really were just atoms, then if we opened up your head and you're thinking about blue elephants, then we should see a blue elephant in there, and we don't. And so what does the atomist then, what is he forced to do? Well, he's forced to say, well, this combination of material things then elicits the blue elephant. Well, Fazer goes on to say, all of your thoughts are conceptually, determinate in a way that matter can never be. So if I texted Dr. Tom McLaughlin a triangle emoji, what do I mean? Do I mean pizza? Do I mean Trinity? Do I mean triangular? Do I mean trilateral? And I definitely do mean one of those things. So there is a specificity, at least to our thoughts, a determination in our thoughts that you just do not find in any material thing. So what do we think of this atomist picture, this priority of the parts to the wholes, and can we respond to it?
You're one person, okay? And the scientist over time is one person. He's not 10 to the 28th atoms. That's one with 28 zeros after it, okay? And so if he's really 10 to the 28 atoms, then where's the person? The person is just a kind of accidental outcome of those many parts. If we begin more from the scientist, like any of us, is one person, okay? We also think there are such things as atoms, but now we have to situate that within the whole. We don't try to say the whole is just an accidental feature of all of these collective parts. But we begin with the whole and talk about, in Aristotelian procedure, you talk about the whole and then you move in and talk about the parts. So the whole is initially grasped in a kind of inchoate, very confused sorts of way. But it has priority, and the priority is not primarily temporal, it's primarily in the nature of things. Now that also in your investigations might be temporal as well. And so When you understand things about the parts, then you've got to come back to the whole and understand how that part fits within what you know about the whole. So an Aristotelian approach is not against parts, okay? It just thinks that that has to take place within a context, and that context is a larger kind of unity. And that's both in the way that we know things, because our initial experiences of things is a sort of whole, and then we can zoom in and focus on them in more detail. But it's also in understanding the being of a thing. So that when, in the example of the person, I understand you first as Austin, okay, and as this person in front of me. And not as 10 to 28 atoms. When I understand water, okay, water is made of hydrogen and helium. These are its materials.
Oxygen, hydrogen, oxygen.
I'm sorry.
That's all right.
Thank you for the
That's why we're here at the table
yeah,
to check you on that.
Okay,
That's great.
make the good one.
That's pretty harmless.
Yeah. So we're understanding water is hydrogen and oxygen. Those are some of its material components. But oxygen is not just hydrogen and oxygen. It's hydrogen and oxygen brought together into a unified whole that is not strictly reducible to the two things independently.
And that's the key.
And that is the key. And that's going to be true throughout the natural world when we're looking at a cell, okay? A cell is simply not strictly a sum of its components, but you're looking at a kind of whole, and you want to understand the parts within that. And the body is typically a very good way of understanding that, because the organs have a particular function within the body as a whole, and you don't want to go to a doctor who doesn't understand that function within the whole, okay?
This is such an important point that we should take a moment and just, for those listening to this, so that they understand exactly what you're saying. Taking that water example, what no one is saying is that water is not constituted out of hydrogen and oxygen, but what you're saying, which is a controversial point, is that what's more real in H2O is not the individual hydrogen, the individual oxygen, it's the new whole that has new properties. And that's why you can burn oxygen, you can burn hydrogen, you don't burn water. You put out fires with water. So what we need...
So when the Hindenburg catches fire and burns, right,
Yeah.
what you get is water, okay? Because it's taking the hydrogen fuel that is in the Hindenburg and it's uniting it with the oxygen in the atmosphere as you get the rapid oxidation.
And so this new whole, I mean, it seems like in chemistry and anthropology, it seems like the whole takes priority. That it's the whole that in some way is determining the properties of the constitutive parts.
And at least you have to understand the properties of the parts within the context of the whole. Okay?
Yeah.
So you can understand the unique contributions of oxygen to water, but that doesn't reduce the water to the oxygen and the hydrogen. It shows you how the oxygen is being used by the whole to give you one thing.
Maybe to play devil's advocate to our own view, you'll come across accounts that, different large-scale properties of water could be predicted ab initio from quantum chemistry. Some of them, yes, but not all of them, because some properties you still just have to put in by hand based off of experiment. So it's not the materialists. We will always have with us. Right?
As our Lord says about the poor, they'll always be with you.
Well, I believe I'm stealing that. No,
Yeah.
I might be stealing that from Father Dewan, or paraphrasing Father Lawrence Dewan. But yes, you still have programs of research that are, how can we predict from the quantum chemistry different, when water will freeze, or when will this compound freeze, or what will it look like in a liquid phase?
I think that's a little bit of how I did math, okay? When I had a math problem, I looked up the answer in the back of the book.
And then you figured it out.
And then I figured it out.
This is where the parts have to...
And supposedly that's what Bohr did in the early formulations of quantum mechanics. He was using chemistry to figure out the physics. And I'm pretty happy with the method.
So what you're saying is those later properties may not be as predictive as we sometimes make it seem to be, having the benefit of being able to look at the end product and then work backwards.
Yeah, and then even if you could, like just to get to Tom's example or his point about hydrogen and oxygen will play a role in that whole, even if you could predict it from quantum chemistry, that's a relationship in prediction that you still have to provide. Well, then the resulting whole has no new reality, even if it's related back to these parts and how they behave. So even if you could predict it, it doesn't seem clear to me that therefore the whole that results is just some sort of illusion.
Would there be any reason that someone would rather just have this reductionist paradigm? It's really just the parts, which are really just parts, which are really just parts. Is there something to lose in saying, no, it takes on a new structure, and this new structure has, we can call it nature, we can call it an essence. I mean, is there anything to lose for our contemporary scientists in conceding a point like that? Or it just doesn't fit into their philosophical foundation currently?
I think a draw of reductionism is a desire for intelligibility that you're explaining. I mean, you can explain a whole to a certain degree in terms of its parts. At the same time, there's something of a kind of arbitrariness. It's like, well, at which level of whole and part are you going to stop? It might be discipline specific. That, well, the brain scientist will take the neuron, the chemist will take the element, the physicist will take the particle. There's a kind of arbitrariness at which is the actual most fundamental. Because if you keep pressing it, then you get to, it's like, well, we don't know.
I mean, could you run into an ad infinitum here? I mean, if it is arbitrary at every level.
Well, that's what classical atomism was designed to avoid, is that ultimately, as you take things apart, you come to an ultimate kind of particle.
The uncuttable.
And that's indestructible. It's not subject to changes
and its behavior is completely determined at its own level. Its behavior doesn't relate at all to
the top.
What you put it in.
Oh, okay.
And that's very different from atoms as they're known today in the sciences. The similarities, of course, are they're both extremely small. You're looking at the ultra small, they're constituents of things. And in some sense, they're fundamental, okay, but not in a limited material sense. And we're going to argue later that there's another principle that is more fundamental than the matter or material out of which something is made.
I think another reason, just to get back to that question about what would a draw to this kind of reductionism be, this kind of materialism. I think another draw is that you can, even if you're thinking about wholes in terms of parts, you can still find you can still find relationships between those different levels of analysis. And so then just to push back,
push back
kind
on
of undermine my own point. Like you realize, oh wait, it's not arbitrary. So the chemist Michael Polanyi has this great comparison to words in grammar, that you could reduce speech to the level of voice, right? Just in the sense of
volume,
phoneme,
okay.
The volume and the phonemes, and then you could study that, right? You could study it with phonetics, and within that you could have words and then sentences and study. You could study it at that level, right? Lexicography or just the grammatical syntax, and then you take words and you put them in sentences and you weave the sentences into paragraphs and speeches, and so then you're introducing style and rhetoric and composition.
Prose.
Yeah, if you take that layered approach, there can be a draw to that, because then you can zoom in on, well, okay, what's your preferred level of analysis, and it can fit. It can fit together. But Polanyi used that image, and so he parallels it with what we've been doing: these elements, compounds, organic compounds, cells, tissues, systems, the whole organism. And then he points out, well, yeah, there's different sciences and their laws or patterns that go along with each of those levels, and you can ask about what's going on at a lower level and how it's being governed by laws at a higher level. Right? Well, why did I pick this word as opposed to that word? Well, because I had a certain stylistic point in mind. So you have a higher level that's determining what's going on at the lower level.
Okay.
So he's really defending this kind of emergentism. The level of the parts informs, it supports what's going on at a higher level, but the higher level does have a kind of independent control over what's going on at the lower level that seems very plausible. There's an attractive intelligibility to it. But then we get back to the point Tom started with. It's like, but you're still one person, right? If we get rid of that as this foundational, I'm one knowing subject, and I'm trying to know about the universe. If that I disappears, we've lost apart from kind of like self-referential incoherence. We've lost the sense of you're a whole, I'm a whole. So there has to be an explanation for that wholeness as such, not just, well, there's all these levels that we can fit together and they happen to get to the whole, because the whole itself, the experience of individual persons and individual things, that was what got us started to begin with. That we took that to be true, and we did. It's kind of like your invocations of the good Professor Phaser. It's like, it's not just we take it to be true; it has to be true. And so if you undermine that, then well, now we're back at square one, and this whole discussion's been an illusion.
Yeah. You lose all your underpinnings for science, rational thought.
Yeah, and I think, given the example that John is using here in terms of you as a whole, the other temptation is to say, oh, well, I'm not the 10 to the 28th atoms, okay? I'm this spiritual mind. And then you're Descartes, and well, how does that spiritual mind fit with all the matter that you're made out of? Well, it doesn't really fit very well, okay? And that's not a holistic view either, okay? So you don't preserve the holism by finding another thing that is really you, and somehow the 10 to the 28th atoms aren't you. No, those are part of you.
That's an important distinction to make.
Yeah,
absolutely.
Yeah. And so how are you both one and many
at the same time?
And it's in different respects. And what we want to do is say that, look, in Aristotle's philosophy, you have an answer to that at the theoretical level.
It seems like, to me, sticking with emergentism, with conceptual thought, it just seems like the higher level is the most determined level. I mean, it just seems like more reasonable to say that higher level is determining the material underneath it than to say, out of these all really nebulous things, you get a hyper-determined thing at the top. Like, it just makes more sense to me that the intellect conceives the concept, which then is, utilizing the synapses and the neurons, which then I can voice. Then the opposite around is, I don't know if I'm understanding it right, but that's just kind of how it strikes me.
The only qualification I think I might add to that is that for you to be a human being, and Austin, there are things that you're going to be made out of that you need. Okay, for your nerves to work, you're going to have sodium. Okay, and the heart is a very unique kind of muscle that pumps blood. Oxygen plays this very important role because oxygen can do that. Other things can't, and so you can't be made out of just anything.
Got it. So the material causality does come into play with the formation of the thing, and then it can also, cause problems with the actual actions of the whole. So I think we've done a good job of laying a foundation here for the future. I would have some specific questions for a couple of things that we've covered thus far. But before we move into the second part of our discussion, what can we say right now in terms of natural philosophy, and specifically a Catholic natural philosophy, so an Aristotelian, a Neo-Thomistic? What can we say, maybe with Aristotle, what can we say he got right from our perspective right now in the conversation? And what did he definitely get wrong? So our listeners know, okay, I can take this, I can continue to think about these ideas, but I don't necessarily have to take these other ones with me.
I want to use this distinction we made earlier about a general philosophy of nature, a general science of nature, and the specific sciences. And what I want to argue is that Aristotle got right the general science of nature, that on that he was mostly right. I don't have a quarrel to pick with him on that. Where a lot of the mistakes show up are on the specifics, okay? So the Earth at the center of the universe, that's a mistake, okay? The four-element theory, earth, air, fire, and water, that was a mistake. The celestial spheres, that was a mistake. And we can talk about any number of these sorts of levels of mistakes. Now, some things in the specifics he got right. The Greeks knew that the Earth was a sphere, okay? And that posed some very interesting problems. Aristotle got kind of right that gravity had to be something central, okay? So that, to put it in modern language, the people down in Australia aren't falling off the world, okay? And so there's some advance there, and you wouldn't want to just say he got it wrong, he got it right. But this would be the main direction I would want to go, is to argue that in the discipline of the general science of nature, Aristotle was correct. He got it right, not that there's an open to future further development. And his errors were mostly in the specifics. And then there were some things in the specifics he got right. I mean, we haven't talked about Aristotle the biologist. And to really get into what did he get right, the level of specifics, you need to get into the nitty-gritty of the biology. But that's my general approach there.
And just to ask you to speak just briefly a little bit more specifically so it can inform the discussion moving forward, what you're saying in general Aristotle got right, I'm assuming that would be things like what is space, what is time, what is motion, the four causes, things like that. Is that what you have in mind?
Yes.
For the general subject?
So the four causes, definition and understanding of time, definition and understanding of motion, understanding of place. We would want to do some little work on that in place because it's a little bit, his general understanding is still a little bound up with some of the specifics. Yeah, his idea that the fundamental constituents of physical things were form and matter, I think he's right about that, as opposed to the fundamental constituent is an indestructible, invariable atom. Okay. So yes, it answered your question.
Great.
Yes.
Great. And I look forward to asking specific questions about each one of those things.
Okay.
And I might add just briefly one of the other things Aristotle got right was how to make progress or how to correct yourself. So when we brought up earlier that you start with more conceptual wholes and a concept of the whole, and then proceed to more specifics in the parts, and then kind of have this back and forth between them. That kind of investigative method, that's one of the things he got right, and he calls it his natural path. He gives this great image of children at first call all men fathers and all women mothers, and only later do they make a distinction. The idea being they learn that not every adult woman has kids and not every adult male has kids. So they in their experience, they draw this distinction, but the example isn't just pointing out the mistake, it's pointing out they were actually correct. These are adult women, these are adult men. And where are your kids? My kids do this. They see it, they meet someone new. It's like, oh, where are your kids? And some of the older ones, they no longer make that mistake. The method points out there's a fundamental basis that we're drawing on that's going to be in general correct. But to make progress, that's where this risk comes in, and you have to measure your progress against more and more detailed experience. So just to, the four elements is an example. Well, why did Aristotle come up with that? Well, his experience of chemistry was based off of what you can touch, the tangible qualities. But for a full range of chemical experience, you have to go beyond what you can touch. Chemists have to interact with things that can burn you and take your skin off. And so there's that conceptual whole of what are things made of. In order to specify that, you have to go beyond this kind of localism, the parochialism, as it were, of your sense experience.
Okay. So I'm hearing you say two things. That's just general advice for any scientists that are out there. The first is you can have more certain knowledge of the general, And so if you feel like you're running into contradictions in the specifics, maybe take a step back and see, did we run into issues at the general level, which is more certain to us, more apparent to us? The second thing I think I'm hearing you say is you need to see the picture of the whole to make sure that you're not messing up the locality. So I guess a correct notion of the cosmos will help inform errors that you might make at the quantum level, or you might make at the physics level or chemical level. Am I hearing that correctly?
Well, not only that, but as Tom spoke to earlier, the scientists are discovering that just in trying to fit cosmology with the other specific disciplines.
Mm-hmm.
I think what happens in the history of science is illustrative of the Aristotle's method and the point that John started off making. So in the 1600s, they're learning a lot about magnetism, that the Earth is a big magnet, okay? That's a development that Aristotle didn't know about at all. That didn't get rid of Aristotelianism. That didn't have the big impact. Figured out that the heart was a pump, okay? That was a big deal, but that doesn't really produce the widespread change in understanding that we know is a scientific revolution. What does it is a change in the whole. And that's the revolution to Copernicus. Okay, it was, the whole, we got the whole
wrong,
mistaken. The whole is really like this, and that, when you view everything in the context of the whole, that reframes everything.
I'm just thinking about gravity. I mean, if the explanation of gravity before was we're just at the bottom of the universe,
right,
now that all has to change.
Yeah, what holds the universe together? Okay, on their thinking of gravity, they don't know. Okay, and so it requires then Isaac Newton to develop within a kind of framework that's very different. When how do you hold a sun-centered cosmos together? And you need to universalize. The answer turns out to be universalized gravitation. It's universal. So, but what I'm trying to do is support the point John made about the importance of the whole and how to make progress. And then what we've started off saying in the beginning is this also happened again in the early 20th century with the development of Big Bang cosmology.
So would you say, you made a statement at the very beginning, a very bold statement, would you say it again here with what we've covered thus far as we move forward? Would you say that the Aristotelian Thomistic picture is more right post-Copernicus, or it's something that's...
Yeah, I would say that since Copernicus, the understanding that we have of the natural world, that we've been getting of the natural world, fits much better with an Aristotelian, especially a Thomistic methodology and some basic points that they want to defend than the ancient specific sciences do. So the whole and the place of parts within it looks much more Christian and much more Aristotelian Thomistic now than it did in 1000 AD or 300 BC.
So as we get down into the specifics, we drill down into some of the topics we've already begun. I'd like to pose what looks like a formidable objection to what we've covered thus far, this neo-Thomistic, this Aristotelian worldview, especially some of those parts of it that you said in general we should hold. And that objection would be the block universe. So we've talked about time, we've talked about motion, but Einstein says here in his letter to Varro, for us who believe in physics, the separation between past, present, and future is a tenacious illusion. So it seems to me, if Einstein's mathematic is right, and those mathematics lead to this conclusion, that it seems like time is an illusion, and therefore Aristotle's notion of motion and time, which is based on motion, all of that's incorrect. So is Einstein right, or is Aristotle right?
Part of what is happening here is in special and general relativity, you can't just think that what we have are three-dimensional things and time is distinct from that and things are changing in time. That in the account we have to include time. And there's a number of reasons for that, but one of them that I think gives us some entry into this is if you ask where something happened, okay, you have three coordinates, you want to know where it happened. To know where it happened, you also have to know when, because there aren't fixed absolute reference points by which you can sort of permanently locate a place. Okay,
Things are moving all
because
the time.
Right. There aren't those spatial fixed points like an absolute center in the universe or something like that. Interestingly, there is a kind of fixed temporal point, namely what we call the Big Bang, or the moment of the Big Bang, or something like shortly after T0. Part of the way one is going to look at the world in special and general relativity is by including this temporal element in it. So if you're looking at an orbit in Newton, you're going to have an ellipse going around a star or something like that. If you're doing an ellipse in space-time, it's going to look a little bit more heliacal, okay? Because the time component because of the way the time component has to be included. So it's almost as if it is subsumed the Newtonian orbit into some larger kind of framework. But when you look at that relativistic orbit, say, okay, what you're looking at is not a body moving around this kind of helix, okay? Because time is actually included as a coordinate. So it's not that it's changing positions over time. All the positions and all the times at which it is are presented to you all at once on the graphics, okay? Now, if you come from a tradition out of Boethius and Aquinas where you have this thinking about, okay, what is eternity? And from eternity, you're going to see all times laid out. By analogy with here in Denver, okay, you go up into the mountains and you can see the highway from way up north going all the way down to Colorado Springs, and all the cars on it is once, okay? So so what you have is a kind of very crude analogy of this sort of Boethian vision from eternity. You see all the times laid out at once. Now, that doesn't mean that all times exist, okay? And if we think about how time is included in general relativity, well, you can, and the treatment of it is kind of a line. What it does is it uses the speed of light to give you time as a kind of distance. So it's somewhat opposite to the way an astronomer will work, because if you want to know how far away something is, an astronomer is going to give it to you in years, light years, okay? There you're using the travel time of light to give you a time measurement. But this is doing the reverse, okay? It is using the speed of light to convert into a distance there. And that's a perfectly legitimate procedure. We use time, distance, and motion measurements all the time. We say it's a long time, okay? Or time is going fast. And we do the opposite as well. And so if we keep that sort of language in mind, and how we are managing to include time into general relativity, and we think about things like I used to love timelines as a kid, okay? And you would think of, okay, this is the Pilgrims landed here, and the Constitution was made here, and now we're here, and you've got it all represented on a line. I go, oh wow, but you could do another line if you're in Paris, or if you're in Nairobi, Kenya, or something like that. Oh wow, how do those lines intersect? All that sort of thing. But it never occurred to me to think that all times were in some sense present, so that the past, present, and future were an illusion, okay? I know how I'm using the timeline here. And I think we don't need to read special and general relativity is if time is analogous to a spatial dimension, so that just as the space over there and the space over there both exist, that so a time in the past and the time in the present all exist. And that change is something of an illusion, okay? Something most of us first encountered in the philosopher Parmenides, okay, who held that motion and time were illusions. And so what I think Einstein has done is he's actually imported a kind of philosophical reading of time, or philosophical notion of time, into his reading of special and general relativity.
Okay.
And that's facilitated by the way that we can use, say, the speed of light to help us do that, and the mathematics, which will leave out all sorts of things. So I don't think that's a necessary read of special and general relativity. You don't find it very common among astronomers at all, okay, for example. I do think...
Just in the sense that the astronomers will assume the universe has a real history.
A real past.
It doesn't
Yes.
exist
It's not
all at
now.
once.
It's not as
And they
now.
have to think about it all the time. So when they're looking at a galaxy like Andromeda, it's 2.2 million light years away. And what they're going to tell you is, I'm seeing it as it was 2.2 million years ago, okay? And they don't go into any of this block universe sort of stuff, okay?
So do we have disagreements then across sciences, or they just don't bother? They don't talk to one another. We're gonna worry over here looking into the stars. We're gonna imagine the
I
time.
could quote you physicists who are famous, who are well known, who disagree with this, okay, in writing.
The block universe is what they disagree with.
Yeah.
So
And they'll point out that if you look at the equations, when you introduce time, there's a difference in the mathematics. It's introduced with a negative sign. And you have to do this conversion by using the speed of light to give you a distance.
Earlier on, Tom was saying that, we've made time, special and general relativity make time this fourth dimension. That doesn't work if you look at the mathematics in the strict sense that it's just a fourth dimension, because to get the three spatial coordinates and the time coordinate to have the same units, you have to introduce the speed of light as a coefficient to time. And so then they all work out into meters,
So
or whatever
like
unit of
if you
length.
have 10 meters per second, I'm sorry, you have your time is 10 seconds, and you multiply that by the speed of light, which is meters per second. What you get is the seconds drop out, and you get meters.
So,
And there are technical variations where you can assume that the speed of light is 1, but that's just a mathematical modification. You still need length and time.
So you need the units of the c to work out with whatever equation you're
Well,
running.
also C represents a kind of universal speed limit, and that is critical. Not only does it let you get the units right, so that you're talking about distances. If you're adding a length, width, and a height, 3 different spatial dimensions, you've got to now add this time dimension, where you've got to have the units right, and it converts the units. But also, it's a universal speed limit, so things can't propagate faster than the speed of light, and that's critical.
So that would be my next question then. If we want to explain the reason the satellite above the world's clock is different than a clock on a guy standing on the sidewalk, can we just say that time is tied to motion and one is moving much faster than the other? I mean, is that not sufficient, that we need to talk about a block universe and we somehow need to put time on a map?
I think it's sufficient because the block universe adds extra machinery that you don't need to understand what's going on. A reply from natural philosophy is that if you don't keep the reality of motion in the picture, and how, like Tom was saying, how motion is tied to the magnitude or the space through which you're moving and the time that it takes to do that, you're really undercutting the beginnings of the theory to begin with. Both the special theory of relativity and the general theory of relativity, they assume that motion is real, and it's frequently glossed over because you quickly get to the mathematical formalism. And in the mathematical formalism, then you're just dealing with the variables that represent space or time. In your philosophical thinking about it, you can be motivated to think, well, this is how the object I'm studying actually exists because this equation describes it in an accurate way. But that additional move isn't necessary, because back at the very beginning, in order to set up this picture of space-time, when you measure distance in seconds, how is that set up in special relativity? You're assuming that light travels, and you're assuming that light, and you actually have to assume that light travels the same constant speed in both directions. which is an assumption because you can't observe
So you
it.
have to remember how you got to this.
So what I'm hearing you say is you begin with an assumption that the block universe is not the case, and you end with the conclusion that the block universe is the case. I mean, that's
But
what
then
I'm
if
hearing
you
say.
if you make that if you get to that last conclusion, then you can't really
Understand.
trust the reality of motion that you started with. So if the conclusion is the block universe shows that past, present, and future are illusions, and so by implication motion is an illusion, then your ability to measure time and measure distances
That went
by
into the-
by relating it to the travel of light, or in general relativity, the assumption of real motion there is that it's tied to the equivalence principle, that with an accelerated frame of reference or a gravitational frame of reference, that you can treat those as equivalent. That's also assuming motion
And the passage of time.
as a consequence, I would say.
Of that motion. All right, so what is alternative then? An alternative conclusion or paradigm to the block universe?
It's to think that time and motion are real. And
Seems like they are.
Okay, and the past no longer exists and the future doesn't yet exist. But just like I can remember things and I can understand a history, and we have historians, we want to say that the universe has a history, it has a past, it will have a future, even though that's not the way things are now. And that change over time that we see in the universe is real, and we use it to date the universe, so that the expansion is the motion upon which we then say that the universe is 13.8 billion years old. To expand to what we see now, how long would that have taken at the rate we measure? Well, 13.8 billion years. We can't skip that.
I mean, that seems like such a simple argument refuting the block universe. Just a year on how long the universe is. I mean, do people not feel the force of that argument that are defending the block universe?
I mean, that whole debate is, just in fairness, it is long and involved. But one of the, just to add to Tom's point, one of the things that the block picture misses is the reality of potency, the reality of materiality. That
Everything
matter
is actual.
If matter's really able to change, if matter really has the capacity and the potentiality to change, that means that its actualizations, what it accomplishes, or this physical thing, what it realizes in the future, hasn't come about yet, because that potency is real. Whereas if you're taking the more Parmenidean, Einsteinian view of the whole thing, everything's actual. And on the one hand, it could be motivated by this kind of algebraic, well, everything is as real as my symbols tell me. But on the other hand, that misses the real contingency, dependency, and limitation of the present is all that exists. The past no longer exists. The future doesn't exist yet. That sometimes it's called presentism. The abilities and the capacities that exist now, whether it's in inorganic things all the way up to human beings, those that ordered interacting set of capacities that is the cosmos, that's actually determining the unfolding of a real history. It's not a slow reveal from this limited perspective that we have in our psychology of what's already been determined, or what already exists in this higher sense.
Got it. So as we were talking about the block universe, we began to talk about potency, and potency leads us to a correct notion of change. Before we do that, I want to give a shout out to Zeno, a couple of Zeno's paradoxes, which I think inevitably lead to the necessity of something like potency in things, and you're going to give more evidence for that here, I'm sure. I was really struck by the two of his paradoxes. One is of the continuous piece being cut into pieces, and he says if any body, so let's say a neutron, is totally actual, then if I cut it in half and then cut that half in half and I cut it ad infinitum, however small that piece is, cut in infinite ways, that small piece, you stack them next to another for an infinite amount of pieces, you would have something that has to be infinitely large. So right now, if this neutron is all actual, there's no potency in it, it would have to be infinitely large. I think that's persuasive. His paradox on motion. If motion is not an actualization of a potency, if I'm actually moving through all of these midways, then again, to get halfway, I'd have to get a quarter, I'd have to get less than that. However small that distance is, shot over the infinite, I would have to move over the infinite in a finite amount of time, which makes motion impossible. So I love Zeno's paradoxes. I think they're very convicting. I think we don't give them enough credence. And I think it leads us to the necessity of something like potency to explain motion, to explain the reality, the being of things. What evidence do we have for potency? And is it one of our best ways of understanding change in general?
I think it is. You have to bring in actualization or actuality also.
Mm-hmm.
The neutron that you cut up into all of its smallest indivisible parts,
Mm-hmm.
and then you're supposed to be able to add them back up to get an infinitely big neutron back. The way I think to bring in potency there is that the parts of the neutron that you're cutting up, the cut, in this case kind of conceptual, you're actualizing what are potential parts.
Mm-hmm.
And so the claim is that you're going to exhaust that potency when you get to something that's indivisible, that doesn't have any size.
Mm-hmm.
So that's actually the point where you can bring in potency to see what's going on, but that's actually the point where you kind of have to cut Zeno off, that you don't have a continuous whole composed of indivisibles. Even if you can, with your geometric compass or your geometric pencil, name any of the potential points
Mm-hmm.
in the sphere. The dichotomy is similar. How Aristotle answers that at first, right? When you traverse halfway, and so you're setting up an infinitely long process, and so there's a sequence of steps, and so the steps are infinite in this infinite series of divisions by two. Aristotle's initial reply is, motion over this span is going to be fine because there's just as many divisions of time that you can make. But that kind of that doesn't bring in potency yet. So Aristotle's deeper rebuttal to that is, when you're in motion, the thing in motion is never actually in any one of those spots along the way. It's just potentially there, in the sense that it could potentially stop there.
Mm-hmm.
The illustration that might help is, if you imagine a wide door frame and there's one guy standing still in the door frame, and the other guy walking through the door frame. If you take your Zeno camera and you take a picture of it right when he walks through the door frame, so they're both in the doorway,
Mm-hmm.
but the guy who's standing still is in the doorway in a different sense than the guy who's walking through is in the doorway, because the ability of the guy in motion, his ability to be in that spot, he's not realizing that same ability in the sense of standing still. He's realizing that ability as ordered to wherever it is that he's going.
Got it.
So wherever it is that he's going is the potency he's trying to realize, and it happens that in ordering his motion to that terminus, it's going to take him through the doorway.
Mm-hmm.
But his act of being in the doorway is distinct from just standing there, because it's realizing the actuality of a different potency.
To be in a place means not instantaneously there. To be at rest in a place is going to involve a span of time.
Yeah, so
So the moving object is never at rest by definition. It's never
kind of
really in the place in a full sense. It's only in an imperfect sense.
Yeah, to
And
be
motion
in motion
is an imperfect reality.
Yeah, to be in motion or to be at rest can't occur in an instant, even though being in motion or being at rest potentially involves instants, where, here's the halfway point, or this is halfway through the time for this motion.
And so if potency is in things and it's in motion, so how do we use this notion of change then to explain maybe some of the diversity in nature or the history of the universe as potency being actualized over time?
One of the things is, I think we have to develop that idea of motion as the actuality of a certain kind of potency, the realization of a certain kind of potency. And one way to do that is to just talk about the order of generation and how that involves Aristotle's causes. And that's following the method we laid out earlier. It's, well, here's the general account of change, and then we can develop it or specify it later.
Okay.
I want to say everyone knows Aristotle's four causes, but maybe not. The material out of which something is made, the form that makes it, it's the cause that makes it what it is as a whole. It accounts for why it's intelligible as a whole. You could take the tree and you could grind it up, and some of it surely goes in, it makes particle board, and others of it perhaps goes in, okay, and then here you have paper. So you have the materials out of which something's made, but its finished form, what it is, the kind of thing it is at the end is due to the formal cause. And then the different agencies that work on that matter, so in the industrial process or in the paper mill, and then of course you have the agents acting in different ways in view of what they want to accomplish. So you just want to make, kind of standard 80-pound white. It's like, well, that's one process, and you set up your materials in a certain way so that you get it. So the four causes there, the matter out of which something is made, and due to the capacities in that matter, determine the array. The array of possibilities, how you could inform something. It permits how agents can act on it for certain ends. Those basic ideas set up this order of generation. And when you're bringing something about, the causes at the beginning, where with respect to whatever's coming into being, they're actually more on the side of what's imperfect, right? The thing that you're bringing into being doesn't exist yet. It's inchoate. It potentially exists because of its matter. It potentially exists because of the capacity of the agent cause that's going to bring it about. But in the order of generation, those agent and material causes are prior in time, and then over the time of the agent cause working out and working on the material, and the material being properly disposed and arranged. At the end of the time, the process achieves what's more in the order of perfection, right? It achieves if we're thinking of artificial things, it achieves the finished product. The form is in place. The end goal has been realized, and it's ready for whatever further use, whatever further ends that you have. Those causes, so the final cause and the formal cause, have really set the tone for the whole process, because the process is aiming at this completed state at the end of the order of generation.
So you should expect, I guess, going from more rudimentary to more complex, more actual, we might say, these things that are just latent in potency, to higher and higher, more actual, whether in their faculties or just in their being kind of things. And you're saying that should be just the natural progression, just looking at what material cause is and what agent, or your efficient cause is.
Yeah. And Tom may have a slightly different answer, but I would say yes and no. Because we had brought up earlier Aristotle's eternal static universe, that there's not really a history. There's the passage of time, but there's not really a history in the sense of you have a beginning and a middle and an end, and you have a kind of this sequence of innovation and change, and you see a totally new kind of thing that you didn't have in the entire history of the universe before. So in that sense, it's no. But on the other hand, there is an expectation that if nature, if the cosmos, kind of speaking materially, is this realm of change, your initial guess might be, well, how does the cosmos as a whole exhibit this order of generation?
And for Aristotle, it didn't. So if you look at Aristotle's cosmos as a whole, you have a kind of hierarchical account. So you've got these strata, and at the bottom is something called prime matter, which doesn't really even exist on its own. And then above that, you have the elements. Above that, you start to have minerals and compounds. And above that, you have living things. First of all, vegetative life. You have then a level of sensitive life for animals. And then above that, you have intellectual life. And human beings are the only known instance of that, of an embodied intellectual life. And that's the sort of hierarchy in the Aristotelian cosmos. Well, how'd that hierarchy get that way? Well, it's always been that way for Aristotle. What's interesting in a kind of Big Bang cosmology is you can now read the order of the cosmos in terms of this kind of generation of the cosmos. So you begin with something loaded with a lot of potentiality and a kind of quark soup, which is just very minimal elementary particles.
It doesn't taste very good.
Yeah.
All potential, basically. I mean,
mostly
raw.
potential. And then you have, after that, you develop atoms, the simplest atoms, hydrogen, then you get fusion, you get helium, and so forth. Okay, and then at a later time you start to get minerals, and then you eventually you've got to get stars, and you get galaxies, and you get planets, and then on the Earth you have complex geology, and then eventually you get the first living things, and then you have a history of evolution, and then you have eventually human beings. And that whole order is a movement from potency to act, from the incomplete and the imperfect to something more complete and more perfect. So in a very rough way, you can take Aristotle's hierarchy, and the higher is now the evolutionary ladder, L-A-T-E-R, okay? It comes later in the history of time. So you can read the history of time from the Big Bang to now as an order of generation where you're sort of, if you're a Christian, is getting the stage ready for salvation history, or of making an increasingly higher kinds of things. And there's some, it's rough, okay, because there's a sense in which plants and animals co-evolve, and you've got to allow for things like that. But the general movement, I mean, in a way, Aristotle and Aquinas' philosophy applies really well to the whole cosmic order. And you might even, on their philosophy, have the expectation that it should have. Because it explains why you start out from the really limited and incomplete, and you generate higher and higher kinds of things. And it, in a way, gives a higher role for matter than you had in the Aristotelian cosmos, because matter goes from something not very well defined at all to now where you have something like 8.7 million known species of living things, which is just this incredible diversity and living things. So these are way higher than 17 elementary particles or something like that. And then you have a kind of culmination in the human in which you have something that transcends the physical order, but which completes it by being embedded in it and actualizing a potency inherent in it. So you can take the Aristotelian stratigraphy and turn it sideways and generate that hierarchy through history. And like I said, it's rough, but it's pretty manifest. And on the Earth, it's extraordinary, given the sheer diversity of things. And in part, one of the things Aquinas held is that for God to do things over time, because God could have just done it like that, everything's there, okay? Better manifests the divine nature and the divine wisdom. To have to work with the materials of the natural order to bring about the kind of perfection that he wants to make better reveals who he is and his wisdom. So if you're thinking that way, then wow, Big Bang cosmology and what we know about the sciences shows that. It shows far greater diversity than either Aquinas or Aristotle ever knew. It's far more ordered than they ever knew. We have over 100 elements, they knew of 4. Our 100 elements show far more internal unity in the periodic system of elements than did their 4. And we have 8.7 million known different species of living things. And bringing all that into a unity is part of what shows the divine wisdom. It's not just sheer diversity, it's diversity in a kind of
an ecosystem.
And you've got to bring it about. Okay? And that manifests a kind of wisdom. So
the divine hand.
So if you think of someone like you or you, all the elements in your body had to be made, okay? And most of them are made in sort of stars. Some of them, like hydrogen, are shortly after the Big Bang. So you're kind of connected with the Big Bang. Almost all the hydrogen in your body came from the Big Bang. The carbon came from a star. Somehow it's got to then become a planet and then get to be you. I mean, that's quite a story. I mean, it's really true to say, in a sense, you're made of stardust. But it's stardust with a whole lot of work going
History,
into
a lot of history.
and then history getting it to be you and me. And that is a wonderful thing to contemplate and to look at, wow, how did that happen?
So we've begun discussing potential material cause, efficient causality, and then this discussion about a hierarchy in being. That hierarchy presupposes that there's an essential difference in things, that the rock is not identical to the grass, which is not identical to the dog, or myself, which is contrary to our materialist atomist notion, which is just me and the table are the same thing, ultimately, just different configuration, quantity of that. So what is this additional causality we're talking about here that's going to define things? It's going to be the essence of a thing.
So the word we like to use is form, which is a word that it's analogous. It can mean many things. But the role that formal cause plays in Aristotelian Thomistic natural philosophy, it's not just, it shows up in different ways. It's not just, well, here's what accounts for the qualities or characteristics of how the change evolved or where it got to. The form of a substance, substantial form, it not only accounts for why that substance is one, so your human form, your soul, why you're one human being, but it's also the ground or the foundation, form is the foundation for why ultimately you're intelligible, right? You have human properties and features and characteristics because they're all tied back to substantial form. The unfolding of different kinds in the cosmos that we were talking about earlier, the substantial forms of things also underlie, they account for how that's possible. Right? A new kind in the universe means that there's a new form.
And you would have to have something that stays the same to have change at all. Change means something being different, B, than was it A. That requires something to exist between A and B, to endure.
Yeah, so on the one hand, the capacity to have that happen and underlie that change is the causal responsibility of matter, whereas the newness and innovation and the specificity of whatever comes into existence at the end of the change, that's the causal responsibility of form.
I think a very important kind of formal principle that John and I would defend is our symmetry principles. And the 20th century is especially marked, 20th century science, by the importance of symmetry principles. It's really superseded, on the words of many scientists, the significance of matter in their work. And a symmetry principle basically reflects some action that you can do to a thing and it looks the same before as it did afterwards. So if you think of a sphere, you can rotate a sphere any direction you want and it's going to look the same. Human beings have a kind of bilateral symmetry. There's symmetries associated with each of the different conservation laws. One of the most important symmetries are called the Lie group, L-I-E group of symmetries. I won't explain what that is, but it's very important to all particle physics. 3 of the 4 fundamental forces all have a symmetry associated with them. And it's a very powerful tool to knowing and predicting and understanding the world that you live in. And I think it's helpful to get a sense of that just thinking by the symmetry of the human person or of animals or things like that. And so the reason I say these are formal principles is they're not matter, okay? A symmetry principle is not matter, even though it's present within material things. And it communicates intelligibility and order throughout the cosmos. So the conservation of momentum, angular momentum, and energy, these are like laws that pervade the whole cosmos, and each of them has associated with it a certain symmetry. So a time symmetry, basically it means whenever you perform an experiment, now, a million years in the future, a billion years in the past, you get the same result, all other things being equal. The same is, let's say I do an experiment a billion light years away. Okay, same laws, same rules pertain there. I'm going to get the same result, assuming I've allowed for everything present in the experimental setup. Aristotle's cosmology, as far as I can tell, did not really make strong use of symmetry. I know of one person who's argued that it has, but as best I can tell, it doesn't seem to be. Where this comes into the sciences is with the Pythagoreans. Then it gets picked up by Plato. And then you have Augustine and Boethius. In the Christian tradition, they're looking at the Old Testament where it says God made everything in measure, weight, and number. And they're taking the connection between symmetry and harmony that you have in the Pythagoreans, and they're saying, oh, the universe has these harmonies, these mathematical symmetries, and there's a close relationship between mathematics and music. And that is a part of the whole Catholic tradition that shows up very much in modern physics. And in both Tolkien and Lewis, you have C.S. Lewis, you have these creation stories that involve music and singing. And that's a play to this very old tradition going all the way back to the Pythagoreans about the importance of symmetry principles and of harmony, the harmony that they establish. And an Aristotelian is going to read that as formal principles, or principles of form.
Is just saying laws of nature, does that not admit formal causality in things? Because how we understand laws is not necessarily something that comes from the outside, it's something in things, right? In movable material things. And so if there's an intelligibility to the thing's movements or how it reacts to other things, this symmetry, when we call these laws of nature, that's a internal law.
It's a principle of, it makes the world more intelligible, it makes it more ordered. Law of conservation of energy, because you have all different forms of energy and energy is conserved. It's a very powerful law. I think there's a sense in which it's internal or intrinsic, like you're saying, but it's not internal or intrinsic in the way a substantial form is to one thing. These are more like intelligibilities that are written across the whole face of the cosmos.
Because the conservation principles that Tom was talking about, so they apply no matter what kind of thing that you are. Right? Or the laws of nature, the law of gravity, it applies to you no matter what kind you are. There's a type of neutrality that's present when we use laws of nature. And so you can take that and say, well, then why talk about substantial forms at all? Right? So why talk about carbon and cats and cosmologists? I mean, they all fall down in a gravitational field in exactly the same way. There's a tension there between the kind of species neutrality of the symmetry, the conservation principles or the symmetry principles and the universal physical laws, and then the very specific forms that the Aristotelian Thomistic natural philosophy wants to posit. Well, no, this is why you're a human being and why this is a cat and why this is carbon is ultimately due to something that's formal. In the substance of it, not just spatially in, but formally in. And I think the way you resolve the tension, at least a bit, is to think of those substantial forms as, well, they're really formal parts within the whole cosmos. So if you want, if they're supposed to be able to interact, then it's going to make sense. You're going to see, and in a sense, you'll need ways in which they can interact and act and react on each other. So you'll see something like the conservation of energy because they're acting and interacting within the same unified whole. So the idea of laws of nature, I think, is right what Tom has said, that they point to form because they're intelligible. But I think what we have to add is that the ground for that intelligibility is form. So things don't have forms because they follow certain laws. They follow certain laws because they have the kind of form that they do. So the forms are
antecedent.
They're prior, or they're antecedent in being, even if it's easier to in certain respects to try to find out, okay, how do they all fall the same way, and so you can get this neutral but universal statement about how they fall. I think another place or instance where we can find not a counterfeit to form, but a close, maybe a cousin to formal causality, is how we speak about information in the sciences. Maybe examples that are closer to home is that we speak of DNA in terms of information. We talk about it as a genetic code. This gets right to some sort of meaning that's being communicated, even if it's just at a mechanical material level. There's a sense in which when we say that the world or the cosmos has information in it, right? We have the different kinds of things following this the same physical laws, or we're able to. There's information present in the universe because of what we can measure and how we can measure it. That sense of information, we want to, I think, distinguish between, well, there's a cognitive or a semantic meaning of information that's not necessarily present
in the thing.
Yeah, whereas why I think it's not a metaphor to use information in those cases is not just the etymological relationship to form that's present in the word, but because of the kinds of parallelisms that you see that, well, so formal causality is responsible for the specificity and intelligibility of a thing, then what we attribute to information, it's performing a similar explanatory role in the contemporary sciences. Sometimes that's encountered as a kind of problem. It's like, oh, well, when we say there's information, it's raining information, or this ecosystem is full of biological information. It's like, that might be taken as a kind of metaphor or anthropomorphism of some sort. But I don't think we have to hold back in that respect. If you have form as a causal principle, so then you can say, well, the physical instantiation of this information that's seated in is due to the forms of these things.
As we're discussing potency, formal causality, efficient material cause, kind of as a refutation of the atomist picture, like Democritus had described it, another way we could probably take a look at deconstructing that atomist picture and maybe vindicating hylomorphism, form matter, is in quantum mechanics. So the farther down we go, it looks like you go from particles to, with quantum field theory, they're saying that these particles are just excitations of a field. I mean, that sounds like, to me, underlying potency that comes into act under certain causal scenarios. So would you say quantum mechanics leans us towards Aristotle? Is it vindicating Aristotle, or at the very least, it's not in contradiction with him?
Well, one of the founders of quantum mechanics, Heisenberg, thought so. I mean, he was very explicit about this. Quantum mechanics is a very difficult subject. I mean, Richard Feynman was famous for saying that nobody really understands quantum mechanics. So I want to kind of have a gentle hand on this one.
There was a physics lecturer that I saw once that started his lectures on quantum mechanics with, currently there's two people there's only one person in the room that's confused by quantum mechanics, and that's me. And at the end of this course, there will be more.
That's really good.
So on an atomism, and by atomism, I really mean atomism in the philosophical sense, where atoms are ultimate beings.
Uncuttables.
Okay? And the idea is that you dig down into the physical order, and then you get to your ultimate particles that are the ultimate beings. They're not subject to being made or being destroyed. There's all sorts of problems on how they unify and dissociate from each other. And I think quantum mechanics was really, and the discovery of the things that led to quantum mechanics, was really a shock to that kind of view. Because it gives you something like, okay, you're digging down, you expect to get the ultimate bedrock.
Firm,
and
solid.
what happens is it's a cloud, okay? And, it's like, there's nothing under there.
Cloud of potency, dare we say.
Or something like that. And what you have is indeterminacy, and there's a limit to how much you can measure things. It's not just a practical limit, but velocity and position are closely related, so that you can only have limited precision on the two of them taken together, and there's a constant, Planck's constant, that is wedded into that. So it's not just a technical kind of limitation. We usually think of quantum mechanics as the science of the very small. So what it especially describes, it describes things within an atom, but it especially describes fundamental particles, okay? And so in the development of quantum mechanics, you also have this huge ballooning and emergence of particle physics. That is the ultimate bonanza of the atomistic approach, is to discover all these fundamental particles. And but the thing about the fundamental particles is that they're subject to coming to be and passing away. I mean, they're not permanent. Now, if they can come to be or pass away, and they're genuinely fundamental, okay, coming to be or passing away means they've got to be composed. But if they're generally fundamental, they can't be composed of some further particle,
right?
Or some further kind of thing or stuff. And what Heisenberg said is that, well, because they're all mutable and we can change them all, that what this really is Aristotle's prime matter is one of the constituents. And Aristotle's prime matter is a sort of pure potency that doesn't have any form or actuality, which doesn't exist of itself. It only exists as formed. But the idea is there is this sort of principle in things that has this openness to being formed, but that openness comes at the cost of not itself being formed. And so it can serve as an explanatory principle for changes from one kind of fundamental particle into another kind of fundamental particle, and then you need its correlative. You need a substantial form by which it's an electron as opposed to a quark.
Something else.
Or something like that. Then in quantum mechanics, when you typically describe something, if you have a particle or something and it's open to a number of different possible states, and you try to determine, okay, what state's it going to be in? Well, there's not a deterministic answer to that. The answer is probabilistic. So, but it's a very interesting probability. You say, okay, I've got this particle, it could go here, it could go here, it could go here. Okay. And when you have to describe its state, you have to include each of those three possibilities, and you have to include them in that each one has a certain probability associated with it, so that the quantum state is a superposition of lots of different possibilities. And if you get confused on possibility, potentiality, and actuality, you're going to say it's over here and over there all at the same time, or it's a dead cat and a live cat at the same time. So it was the combination of having very distinct possibilities but not being determined to a single one that led Heisenberg to say, oh, this introduces an element, a principle of potentiality into modern physics, and he explicitly cites Aristotle. On both of these, prime matter is underlying fundamental particle transformations, and then explanations of the indeterminism and the multiple states in which a quantum system can be in as indicative of potency. Because if something's potential, it's indeterminate. It's not determined to some one thing. It has to be determined by some kind of agency. And Feynman put this in a really kind of stunning way. It's like nature doesn't know what she's going to do next. It's a very anti-deterministic kind of thing, at least at the quantum level. But if you're thinking in ancient atomism, you don't have potencies, because that means you're changing the fundamentals and the fundamental being, and the fundamental being isn't subject to change. So explanation then doesn't really, you don't have something that explains, a kind of particle that explains everything. So that fundamental particles are explanatory in a fundamental way, but in a limited fundamental way, and form is going to be the more important fundamental particle. So your atoms or your electrons or your quarks are not going to explain everything, and their explanatory power is going to look rather limited in comparison to what an ancient atomist would have viewed as the explanation.
Particles in quantum theory, they don't, unlike ancient atoms, the ancient atoms were context blind. They didn't care what they were put in. They themselves weren't affected. Whereas if you compose different kinds of things into carbon or some other element, how the Schrödinger equation for this atom versus that one, what it looks like is different because how you've composed those parts into a greater whole.
So this is really, really cool because the fundamental particles are loaded with potentiality is a way that we would kind of put that as a kind of analogy. So that makes them very receptible to being united and put together. When here's the physicists are, well, it's really more of a field, is it a particle? On an Aristotelian account, at this very close to prime matter level, you're one step removed from prime matter. You're looking at the elements. There's not made of anything except prime matter in a form. They're barely going to be there. Okay, so this is the opposite of the atomistic view. And they're very hard to describe in the terms that we're used to. Because when we think of something that's not very unified or one or very strong in being, we tend to describe it as a kind of mixture. But that's not exactly what they are either. It's not like they're a heap or something. They're just
indeterminate in themselves.
To a very great extent. And so you're looking at something that, it's trying to think of a cloud in concrete, as if it's heavy and resists you. But no, you can fly through the thing.
Eddington had a great phrase for that the two-ness of two electrons is not like the two-ness of two apples. Right? We think of like, here's one apple, here's another one, and this.
But it's that indeterminacy. That's why they call them like electron clouds.
Yeah.
Right? No, we don't know exactly where it is.
And that's a kind of analogy, and that's how we have to know things that are this far removed from human experience and this indeterminate, is you have to work with a kind of analogical understanding, and that's really, I think it gives a physicist a lot of trouble. It's a hard thing to do.
Two questions. The first is, what I'm hearing you say is, maybe before the discovery of quantum mechanics, maybe there was a notion that the further down we go, the more solid we're going to find things. But what we actually found was greater indeterminacy, which is exactly what you'd expect if Aristotle was right.
Exactly.
My two questions are, when I looked at the double slit experiment, as soon as you place that measuring mechanism on the other side of the two slits, and as soon as it's able to read which slit this particle goes through, you determine it collapses the wavelength. I mean, that just looked like, to me, going from possibility, wave-like possibility, being affected by an efficient cause, which is now determining you, to something less, indeterminate. Is my read on that correct? That's my first question. My second question is, so I think Heisenberg, if I remember that quote in Physics and Philosophy, he does say explicitly we should compare energy to prime matter. What would be your thoughts on those two things?
Well, this is a long discussion, so I would say no. But here's why. So energy is, I would argue, very Aristotelian, and you can get a wonder about that just from looking at the term. So energy, that's comes from a transliteration of Aristotle's Greek, energeia, okay? And for Aristotle, so the etymology, the language suggests that it's Aristotelian actuality. It's Aristotle's term for actuality. And when Aristotle wants a correlative term, he says potentiality. Okay. Now, that term enters physics, not with quantum mechanics, but it enters physics around the 1850s, and it's a physicist named Rankine, and he coins the term potential energy, which I take in a very straightforward way as a potency to energy, a potency to act. And Rankine is very explicit. He draws the term from Aristotle, and he even quotes Aristotle in the Greek. Okay. They were more educated in a different way. Okay, so if we imagine, I'm going to take your pen. Okay, if we imagine the pen. Okay, the pen is a certain distance above the table, and if we think of it gravitationally, it has a certain potential energy with regard to the surface of the table.
MGH, isn't that the
MGH, exactly. And so the reason I want to say that's genuinely potential, that potential energy, is because it involves a relationship to a position that it does not have, actually have. Okay, and so I would say it then has that potentially, and it's when it comes down here, it's actual, and we have a different energy there. Now, so potential energy, and actually as it falls, it gains kinetic energy, and kinetic energy is clearly actual because it's the energy of motion. Okay, so that's all. It seems to me fairly Aristotelian. I would also want to say there's a certain kind of energy when I put it here that I have built into the pen, because I had to raise it up.
Oh, okay.
So there's a sense in which it's got a kind of actual energy here, and it's also potential to being here. And that's very Aristotelian, because all potencies are in some way going to depend upon an actuality. I mean, that's kind of just real fast.
Great,
but I think if you look at the physics of energy, it looks like you're dealing with very broadly Aristotelian principles in which the present understanding goes way beyond anything Aristotle thought about them showing us of the specifics of the physical world. Now, it doesn't go beyond what he thought in terms of, I think, prime matter, in terms of potency. And then we speak of different forms of energy. That would not have surprised Aristotle, that you have different forms of act
coming out of potency.
Yeah, but that's a whole long conversation. So.
I want to loop back for a moment to speaking about the mechanistic philosophy and trying to get rid of teleology, finality, goal-centeredness in things, because I think it's just so unnatural to us. I remember when I was a Carthusian, we were sent to one of the brothers' cells to help with his garden or something, and in his garden was this massive tree, which they were trying to cut down because the roots were going into the cell, into the stone of the cell, and they had begun cutting into both sides of this tree, and the tree had grown a ring of horns around where they had begun cutting into the tree. So I'm watching this tree try and defend itself. And when you see things like that, or another example, when I learn about the path that light takes, that doesn't take the most direct path, but it takes the path of least time, and apparently that's why we see mirages on the road. So I'm driving, and because of the heat on the asphalt, the air is less dense closer to the road, and so light traveling to my eye will bowl down before reaching my eye, and that's why I'm seeing the sky on the ground. I mean, that's what it appears like. Well, to be able to do that, to be able to take the most efficient path between 2 points, requires knowing where you want to get to before you begin moving, and it requires knowing the mediums in between those two places. And I use the word know loosely, but whether I'm looking at the tree growing horns, knowing it's being attacked and trying to defend itself, or I look at light traveling to me on a hot day, the world just looks smart. It looks like it has goals built into it that it is pursuing in an intelligent way. How do we give an account for this?
So an Aristotelian or a Thomist is going to talk about something called final causality. And final causality means what we think about a goal or an end as a kind of cause, right? That at which something aims, or that for the sake of which something acts. And we typically think of goals as having to do with a mind. You can foresee the goal and you aim at it. But you don't have to have a mind in order to have a goal. We make machines that have very definite goals, and they don't have a mind in them. They're made by a mind, and that becomes a crucial issue when you're thinking about the reality of final causality. Does there have to be a mind somewhere? We think of it as a kind of target. So in the history of philosophy and the history of science, the last 400 years have reflected a really extraordinary revolution, rejecting final cause explanations from nature. okay, and more toward the human being as well. Now, that you can see just on the face of it is going to give rise to something really weird, because that means human beings are very purpose and meaning-driven creatures. And you're saying we live in a world that's just has no point, has no meaning, has no goals. That's alienation like Marx never dreamed of, okay? So I want to refer to a physicist I like to read a lot named Steven Weinberg, who passed away a few years ago. He was a Nobel Prize winning physicist. He was involved in the unification of some of the fundamental forces. And he wrote a couple of books in which he was famous for the quote, "The more the universe seems comprehensible, the more it seems pointless." And then he commented on that later that science doesn't say that the world is pointless. It's just that the world doesn't show any evidence of a point. It doesn't show a point. But that we can invent purposes, we can invent goals, we can invent meanings for ourselves. Now, this is a very odd thing for a scientist to say in that way, because the universe is intelligible. That's why it can be comprehended, why we can comprehend it, we can understand it. And that intelligibility and that comprehending of it, I think, is a manifest and objective good. And scientists act that way. And Weinberg's book defends that activity to find a kind of unified theory of everything, and he anchors it in both nature and in the history of human intellectual activity. And so I don't think a scientist needs to invent a meaning to what they're doing. I think the more people believe that they're inventing a meaning to do it, the less interested they're going to be in science and the less willing they will be to contribute money to it. It's just a thing that they do that makes, that they kind of cooked up. And I don't think that's true to the scientific endeavor. On an Aristotelian or Thomistic count, the final cause is special of all the four. It is the cause of causes, which means it's the cause of the causality of the other causes. So another way of getting at this with regard to the efficient cause, the agent, is that an agent can't act unless an agent has a goal. So if I were to say walk, I have to have somewhere to go or some direction to go. I can't just walk.
Exactly,
okay?
Yeah.
There can't be any activity unless I aim, even if it's in some sense, I'm going to be random and I'll go here and then I'll go there. There's got to be some sort of
willed choice,
and that intentionality in things that don't have a mind or even senses is built into them. So an example might be gravitation. That in Isaac Newton's universal law of gravity, he said he didn't know the cause of gravity, meaning he didn't know the efficient cause. But what he knew was the destiny. He knew that the tendency is to come together, to unify toward a center of gravity. Okay? And that is a kind of end or telos, and then we could get into a further discussion as to whether or not that was a good. But laws, if we think of laws of nature, laws are teleological. I mean, it's an unusual thing that has happened in the sciences at the time of the scientific revolution, where you begin to embrace the notion that nature is lawful, okay? And there's a long tradition behind that, coming influenced by both the Ten Commandments, Roman law, and other things. But to say that nature is lawful but not teleological, because a law orders. It basically is, this is where you're going to do what you're going to do. This is what is how you're going to be directed. Okay, even if it's not conscious. And so it's very hard to understand what a law that is not but it's not teleological. What would that be? Because it's directing toward an action or a kind of state. I think I would just encourage people to look especially at all sorts of living things and other things. And I think you can see teleological activity. You can experience it with things, and we'll talk about that a little bit more as we go, especially as we get into living things. But.
Because it's especially in living things where teleology is manifest, like you said, and the goods that are acquired at the end of an action, they're more manifest in living things. Just a quick note on the use of law. It seems like the tendency is to talk about law-like behavior or law-like action, or you could even think of something like, the law of sines and cosines. It's like, well, there's no good. Like, what's the good that's going to come out at the end of the calculation, apart from, I guess, getting the answer right? But so the law of sines is not. It's kind of an extended use of how we use law. Yeah. But then you can just think of behavior according to a law in this kind of neutral way. Like, you could think of walking and you're just kind of going, but there you're arguably you're abstracting from, you're ignoring what makes the walking not just intelligible but possible in the first place, namely the goal towards which it's headed. So there's ways you can
and it's
pair away good.
Traditional Thomism say that mathematics abstracts from final causality.
Yes, you can pair away the kind of weightedness that the good has, that the trio from the Book of Wisdom that Tom quoted earlier, that
number, weight.
Yeah, thou hast sorted all things in measure, number, and weight. Augustine picks up on that, and for Augustine it's mode, species, and order. And so then he doesn't, but then Aquinas St. Thomas picks up on that and compares those to the four causes. And so those, but what's striking is measure, number, and weight, or mode, species, and order. Those are the agency and materiality measured and arranged, and then given a certain number of species, that is a form, and then they're ordered or inclined to a good. So you're really looking at this, so the measure, number, and weight of things, that's everything except the good, but you're supposed to see in that order and that intelligibility that it's dependent upon a good. Another way you can see final causality in nature, apart from the more manifest, kind of closer to home examples, I think if principally my go-to is going to be the principle of least action. This gets to something of what Tom has spoken about there's a contemporary analog to place as a kind of goal, even when we're talking about gravity. But the what's paired with a natural place in Aristotle's model is a natural motion to that place. So even today, we'd still want to find, okay, if Aristotle's wrong about the specifics, is there still a way to talk about a natural motion? And so one way to do that is to point out, well, there's still approximate analogs to natural places, even just for gravity. Pierre Duhem also compared natural place to just a bit more broadly across the sciences to where a moving system finds its point of equilibrium, so a kind of rest when it's, so to speak, run its course. But one of the mathematical tools that I think helps to show that natural motion is still present is what is sometimes called the principle of least action, or the principle of stationary action. And the scientists who first came across it, even they compared it to a kind of teleological ordering of the universe. And so here I think a helpful example to just start getting the point across, we've now alluded to Feynman twice. This is also an example from Feynman. He uses the case of a lifeguard. I mean, of course, Feynman lived in California, so of course it's going to be a lifeguard.
Yeah.
But a lifeguard, sees someone struggling in the waves some distance away. So you want to get there as quickly as possible. So even if you're a fit California lifeguard, how are you going to do it? It's like, do you run directly into the water and then swim out to them? It's like, well, no, you even if you're a good lifeguard, you're probably going to be able to run faster than you can swim. It's like, okay, so do you run all the way down and so you're as close to their point away from the shore? So there you're running a further distance and you have to swim less. But won't that greater distance over land still waste time?
Yep.
So it's somewhere, the lifeguard's not going to do this, hopefully, while he's trying to save you, but it's somewhere in between, so this balance between least time over sand and least time through water.
Yep.
It says that's also found when you're talking about the path of least time. So laws of refraction, you can derive laws of refraction using that if you assume light will take the path of least time. And then you calculate, okay, what's that path going to look like? Then you end up with the observed law of refraction through different media. So this idea of natural moving things, when they spontaneously act, or just how they naturally act, so not when we're interfering, or some other agent is interfering with them, there is this kind of efficiency with respect to time that arises. And so when you bring in the energy it takes to move, so then you get this nice unit called joule seconds, not joules per second, but joule seconds as a product. And so then the analytical mechanics will look at, okay, what's the formula for a given system, like a pendulum or a falling body or a projectile, or more complicated systems, gravitational systems. What are the equations of motion? What are they going to be? On the assumption that this moving thing, where it begins and where it ends, over the course of its motion, it's going to minimize the quantity joule seconds, or action. And so there's a family of functions. So the Lagrangian keeps track of that. Yeah, you can map this all out mathematically. But yeah, if you think about that, that's already a kind of holism that's not present in typical Newtonian mechanics. Newtonian mechanics, you start with the usual way you do it. I should qualify you start with the point particle, and then you have to integrate, according to the law of motion, you have to integrate the motion path. So you're starting from this indivisible point. Zeno is back. You're starting from this indivisible point and then getting this motion path from it. Whereas the least action analysis, you have beginning and end, and so you essentially ask, okay, what's the most efficient or effective route in terms of action over this beginning and end point. Now, those two pictures that kind of start with points versus start with a whole path, you can mathematically go back from one to the other, but different physicists point out that least action is a principle that survives. It's not only in classical Newtonian mechanics, but there's an analog for it in relativity and general relativity, and there's an analog for it in quantum mechanics. So it's a principle that shows up across regimes that are technically, especially with quantum theory and gravity, we don't know how to fit them together. But it's something that, so that means you get along implied principles like the principle of the conservation of energy. So you have something that's more universal.
It's one of my favorite sayings. One of my favorite movies calls it the most important principle you never heard of.
And is it true to even evoke the word efficiency? You're implying goal. You're implying goal and taking knowledge, the existence of a goal and knowledge of goal, which is going to be headed towards.
Yeah, I'd want to take that in a few steps, just not all at once, right? The mathematics, kind of by design or by its deliberation, ignores that. It's not concerned with, is the moving thing, is it in a better state at the end when it reaches the end, right? So if you come up with some complicated Lagrangian for how the water is going to flow downhill, and then it's downhill and it's resting, the mathematics just tells you about the path. And so, like Tom had mentioned earlier, it abstracts from the goal. But along the lines of, well, if in this broader perspective it's the final cause is the cause of causes, and part of the causality that the goal causes is how different kinds of things are ordered to achieve that good or that end goal, it would make sense that in measuring and trying to quantify aspects of all of these interacting kinds, you will see a pattern, you'll see a law-like structure that points right to that endpoint. It's just from a broader perspective, you're going to be able to see the endpoint as a goal, as something that's... So you can't read off goodness from the Lagrangian.
Got it.
But the Lagrangian doesn't deny the existence of goodness.
So I think one of the examples I like is bees. Bees make their cells in these
Hexagon? Something? Octagon?
Is it an I
don't know. You know better. Hexagon?
Okay. And
Octagons would be really hard, guys. Come on.
Yeah. It's like, isn't
Why that shape?
Why that shape? And it turns out that what it does is it maximizes your space with a minimum of honey.
Because you can tile hexagons.
There you go.
You can't tile octagons.
So you can get a lot more
It's
space
fascinating.
for the minimum amount. And there you can see, that's a good.
And then
If it cost you 5 or 10% more as a bee, that would be a downer. I mean, it would affect your survival. It would affect the reproduction, the care of the young, everything.
maybe an easy transition here would then be into kind of the development of species, the development of the bee. I mean, just in evolution in general, just the fact that things move towards maybe higher kinds of species or the hexagon shape as opposed to a non-efficient shape. I mean,
the octagon bees, we don't see any.
they're gone. Yeah.
That was a bad choice. Okay, it wasn't a choice.
We're gonna dig up relics one day. What is this octagon-shaped beehive?
They're gone, man. I didn't.
So I mean, is just the direction of evolution sufficient to prove some kind of teleology in nature?
We'd have to say what we mean by direction, right? In evolution.
Maybe more actual, or is that and is that like begging the question towards?
Well, because the biologists don't like to talk about a directionality to evolution, and I think they have, in a certain respect, they have good reason for it. That they're analyzing. So if we think of evolution as an account of the origin of new species in terms of inherited adaptive traits that provide some new functionality. If we think about it in those terms, you don't have to really think of an overall direction to evolution to analyze it at a closer scale and just kind of map out the so-called tree, the tree of life and the phylogeny of different species. But yeah, at the same time, even that finer grained level, it's never really seemed realistic to me to eliminate all talk of teleology. Now, some of that it comes with to a biologist, it might come with this association with design arguments, or that you have to be a theist in order to accept it. And so some folks come up with different words, like Ernst Mayr coined teleonomy, and so we'll talk of teleonomy instead of teleology. So okay,
just so it's easier to stomach, kind of thing. Is that
and so you get it just terminologically, you get away from. No, I'm not talking about this kind of thing.
God or something like that.
I think what John's saying, I would agree with, is there's a distinct questions. Do you have teleology in the world? Yes or no? And you can address that question. And then you could address whether that implies that there's a God. Okay.
Yeah, definitely.
And I think they're distinct questions. And I think John and I come down on the side of yes, it implies a God. But we recognize the distinction of the question.
Yeah, what you don't want to do is, and Descartes knew better, but when Descartes argues that we can't inspect the final causes of things because we don't know the mind of God, like he had to have known that was a sophistical argument, because it's not, you don't have to know the mind of God to know that why is that beaver gnawing on that tree? Is it crazy? It's like, no, it is a fine beaver. It's part of. I mean, it's a natural part of its function, and so it needs that to.
When I came to Colorado, people warned me about bears, and when you see a bear cub, you're in trouble. Right?
Don't even know the mind of God to figure that out.
No, and if you have to consult the mind of God,
you're in trouble.
You're in trouble.
You're doing it at the wrong end for it's just the notion of function, right? So the way evolution is phrased in terms of which I haven't. I've seen philosophers of biology try to redescribe it, so you're no longer talking about functions, but then that just becomes, I think, a bit unbelievable. And it's the biologists don't talk that way. It's like, what does this thing do? What is its function?
Yeah, exactly.
What does it achieve? It's like, well, okay, so there you're talking about final causes and teleology. What other species in its habitat does it need to survive and to do well? It's like that's teleological language. Even built into evolution, there's a kind of teleology. We mentioned Ed Feser before. Ed Feser has a nice little paper on the paradox of evolution, which that's a phrase he's borrowing from other biologists. That so if evolution, and biologists who are careful they don't say this, but evolution is not a theory about the origin of life, right? It's a theory about the origin of species. And you assume that you have life already, and you assume that you have life that can reproduce. And the reason for that is that the ability to reproduce. You have to be careful. Okay, can that be a trait that some prior generation of living thing acquired and then passed on? It's like if it were the very first kind of living thing, sure, but the ability to reproduce can't itself be a trait that's inherited evolutionarily as some new advantageous adaptation.
Because you wouldn't have other.
You have to assume that from the very beginning, and it's not. It doesn't fall under the scope of the theory. But reproduction is clearly teleological, right? The whole process is ordered to producing a new individual of the same kind or an adjacent kind
of species.
Teleology in the small, I think, is not very negotiable even for an evolutionary biologist. It's the bigger question is, okay, overall, does it have a direction? Overall, does it have further theistic implications?
I think sometimes when people speak about chance and the role of evolution, of chance in evolution, because what you have is a certain random variation for which you then have natural selection. And they think that's the end of the question, is if chance and teleology are opposed in such a way that if you say this is due to random variation, that's the end of the question. And I think it's important to recognize that chance and teleology are opposed if you're thinking about the same event at the same time and in the same way. I'll give an example. But if you're thinking at different levels of reality, something can be very teleological and very chance at the same time. And we know this for people who are serious card players or serious poker players. It's a very purposeful game. It's driven by a lot of goals. And it's got a lot of chance in it. There's various odds and various probabilities that you're going to draw this, you're going to draw this, you're reading your opponents. There's an awful lot that goes into using the chance elements of the game, but you're using it for a very directed purpose.
Got it.
And a good card player will hold himself to that. He's not going to just toss something out there randomly. Nature is like that too, and it's easiest to see it probably in the area of reproduction because all that pollen, that causes us allergies and stuff, that's reproductive. And nature uses this sort of swarm strategy, There's a gazillion sperms going after the egg, but only one gets it. That seems so wasteful, It's like a mother alligator has 100 alligators, And 93 of them are not ever going to make it to adolescence, But the ones that do, they're playing the odds. And nature plays the odds. And playing the odds is a strategy. It can be a goal-directed strategy. So I think it's important to see that these two things are not strict opposites,
I think one of the motivations from secular scientists to really press into evolution and discuss it might be to bring humanity's place down as being a unique part of creation, as something that's within creation but might have a spiritual aspect to him. That's what I've seen in my experience. Evolutionists want to say that we really are not that different than those steps which are before us. So what would we say, having discussed evolution, what would we say of man's place in the cosmos?
Scientific revolution is often interpreted in the way that you just described, is showing that the human being is just completely insignificant in the cosmos. or bring his place down and shit. The problem is it was already down, okay? So for Aristotle, the center of the cosmos is not the most important place. It's the least important place. And the way to communicate this intuition for people who haven't read Aristotle is to think of Dante. What's at the center of the cosmos for Dante? Well, it's Satan, okay?
Frozen.
Yeah, frozen, okay? Traditionally, in religion, the bad place is down and the good place is up there.
Mm-hmm.
Up there is where the good stuff is. And so that was Aristotle too. The human being was maybe the most important being under the moon, but up above the moon, there were these great ensouled spheres that were everlasting and vastly intelligent, okay? So that was a problem for Aquinas and for Christians generally. Copernicus in the Copernican Revolution is one of several of these giants who bring about this change. Copernicus, Galileo, we all know of, and then Kepler, who gave the 3 laws of planetary motion. All 3 of them thought that the Copernican Revolution was an elevation of the human person. That part of Copernicus's concern was that the cosmology that he had inherited was a mess. The parts didn't cohere into a whole, and he think God would not have made such a messy world for our sake. Okay, and so you get this for our sake, for the sake of the human, that's important to Copernicus. Galileo sees the Earth as, because it's a planet, it's one of those things. And so it's elevated into the heavens and it joins the dance of the stars. And so it becomes part of this larger heavenly community. And then you see something similar in Copernicus, where moving the Earth, so the Earth is now orbiting the sun, makes the Earth a much better place from which to do science and to do contemplative studies and things like that. And that's been emphasized by a number of other people in terms of location in the galaxy and so on and so forth. So it's this sort of great cliche that what the scientific revolution did was show how insignificant we were because we weren't in the center. Well, the center wasn't an important place, okay? It was the least important place. And if you think about it, what's the most important place in a church? It's not the it's usually not the geometric center, okay?
Yep.
And that helps understand that geometry is not the same thing as a figurative or valuational use of place. And then in terms of size, the ancients knew we were small compared to the cosmos. I mean, the Psalms, okay, what is man that thou art mindful of him? When you look at the stars. Ptolemy, the great ancient astronomer of the 1st century AD, said, the Earth, in comparison to the size of the cosmos, is but a point. I mean, it doesn't have hardly any size at all. And then Boethius repeats that, and so on and so forth. So our worth is not because we're big, okay? So all those bigger people out there aren't more valuable from us because they're 6'3" or something like that. I think it's important to see that Galileo especially saw the Copernican revolution as an elevation, okay? And I think that is part of the story here, is to get that swept out, this notion, and to really address what is the significance of the human person. Let's really address that question and not just try to immediately shoot the person who asked the question by saying, you're a dummy, don't you know that the scientific revolution shows. So I'd actually like to pick an atheist on this. I used to listen to Carl Sagan some. And one of the things that Carl Sagan used to say about human beings was human beings are a way, and he would say this with this mystical, really moved, which was kind of cool. The human beings are a way for the cosmos to know itself. Now the thing is, that's exactly what Aquinas would have said, dropping the naturalism. That was a kind of special Aristotelian Thomistic, and probably other ancients held this as well.
If Galileo and Kepler and Copernicus saw the heliocentric shift as ennobling us, as making us part of a heavenly order, I mean, it seems like it's possible to take this philosophical account of evolution does that make us just one last step in an essentially materialistic process? Or is that's not actually ennobling to the degree that one could what it means to be alive, or what it means to be a primate or a hominid?
Mm-hmm.
There's actually a kind of perfection to those species in this evolutionary lineage. If you do read the cosmos teleologically, and if you have in the background that a materialistic or a mechanistic account of living things isn't fully believable, that it makes the evolutionary process, it allows you to see in the evolutionary process something that's more noble than, it makes use of chance and random variation, but that's folded into this overarching means that nature has towards diversification. I don't know if Aquinas would have said it the way Carl Sagan did in those precise terms, but it's at least true that Aquinas he argued in many different places that the universe would be incomplete, it would be imperfect if there were no intellectual creatures.
To know it, at the very least.
Yeah,
right?
He gets that. Many of his arguments are what you might call a bit top-down, that they start with an account of creation and God's intention in the creative act, and that the form of the universe should take on, to the extent possible in God's creative wisdom, it should be an imitation, a likeness of God to the degree possible. And there's always a further possible degree, so you have to pick one. But part of that overarching argument is that, the completeness of that universe that God is making should include intellectual creatures, because God is intellectual. So if you didn't include an intellectual kind, then at least at the generic level, there'd be a missing piece in that universe. It would look like a kind of, in this metaphysical perspective, it'd be this mutilated kind of universe. I think you can also kind of take instead of a top-down approach, a more bottom-up approach, that over the course of this natural history of the unfolding of kinds in the cosmos, especially when you get to living things, then you get to types of things that have greater and greater degrees of freedom. They can determine more about their lives. Less is determined by instinct and more is determined by behavior. They're able to do more. From the bottom up perspective, if you'd be missing you'd be missing a rank of operational freedom, or if you didn't have a creature with intellectual capacity.
The voluntariness, because right below us is instinct.
Well, they're right below.
There's some nuances
it's below
there.
us. It's below. Yeah, I mean, we do have instincts.
True.
And then, depending on which animal you look at, you're gonna have more learned behavior and more adaptive behavior, and then higher levels of cognition. If we put it all under instinct, I guess that's fine if it's a very generic use of instinct. Whereas it's not instinct in the sense of the French entomologist Fabre looking at insects, and I mean their adaptive behavior is almost non-existent.
Got it.
So they're much more instinctive.
Got it. Yeah, than the higher level animals.
I think also you can argue, if you take something like the sequoia, and pick any animal or something, or pick Mount Everest, the sequoia can't tell us, it can't say how wonderful it is. It can be wonderful, but there's nobody to sing, without an intelligent creature, there's no one to sing its praises.
Yeah, we need that priest.
And that's a really significant thing. It's significant for the whole order, for the little electron up to the blue whale and the T-Rex and the elephant, okay? To sing that song and to say, look how wonderful they are, and to know them, and to be able to understand how they are also in a way related to each other, and to see the T-Rex as, is part of the history that leads, or is part of this long history of Earth, and to bring, because that history exists stretched out, and those things don't all coincide. And likewise, with different places in the world or different places in the solar system, the universe. What the human being can do is sort of collate that and bring it into a kind of unitary vision in a very imperfect way. And that is an achievement that the universe does through the human being, and God does in creating.
So Sagan was speaking a bit poetically, right? Taking the naming the part by the whole, that the cosmos knows itself. That the cosmos knows itself through the operation of one of its parts, and that like Tom was just describing, the whole history and the whole range of the cosmos is intelligible. So there's a potentiality there that's not going to be realized if the part that's able to know it isn't there.
Got it.
And it seems built to be known. Why in the world is Saturn beautiful and stunning and radiant? And why do you dig things up way under the earth that
happened?
They didn't have to be beautiful. Saturn didn't have to be beautiful, but Saturn is. I think that the human being, or if there are creatures like us anywhere else in the universe, that's an extraordinary role that we have as a kind of amphibian, as a kind of creature that is rooted in the physical world and part of it, but has a spiritual soul by which we unite the two realms.
As we wind up our discussion here on the cosmos, rediscovering the cosmos, some of these fundamentals, getting a truer vision of the universe we exist in, two things I want to discuss here at the end. The first is, as an evangelist, as a Catholic, we're all Catholics, what are the implications of what we discussed on the existence of a God? Have we lost any of Aquinas' proofs? Are there some that have been vindicated especially? And then after that, what can we say about the creation of the universe and some different ideas about a multiverse? But beginning here with proofs for the existence of God from what we know from the natural world.
I think there's a lot we can say about proofs for the existence of God based on or drawing from the modern sciences. Even though it's a longer conversation about Aquinas or classical theism, I think that Aquinas' 5 ways are still sound. So the progress in the sciences hasn't undermined the essential core and vision and articulation that you can give to those principles, even though, kind of like we've talked for Aristotle, even if the details of how you specify or concretize what the ways are talking about, how the 5 ways are describing the universe, even if the specific details look different. When thinking about the contemporary sciences, I tend to gravitate towards the first way and the 5th way. So maybe we could just sketch out what those could look like, because there are book-length treatments doing this in very great and fun detail. So the first way is commonly called the proof from motion. So the way to God's existence, you start with the existence of motion. One of Aquinas' formulations for it, in a nutshell, is that everything that's in motion is put in motion by some mover. And if that mover itself is in motion, so if it's a moved mover, then every moved mover has to be moved by some first unmoved mover. So then you can connect, so everything in motion is ultimately moved by some first unmoved mover. So that gets you a way to, there exists some first unmoved mover of the universe, and so that's what we can call God. So after that, then you have to unpack, and how can we connect that limited causal notion of God to a broader
divine
picture, to a broader picture of Catholic theism. That's kind of the basics of the argument itself.
Simple.
How I think of that in terms of the contemporary sciences is that it involves the notion of a system, a moving system. So instead of a moving substance. You kind of broaden the notion to a system that's put in motion. And scientists like to talk about closed systems, open systems, or isolated systems. A system is any group of objects, right? It doesn't necessarily have a natural unity to it. It's not a substance. So it's any group of objects that you've grouped together, at least mentally, to investigate. So of course, then you want to do that carefully so your system is relevant, so that it provides helpful information. So then you could think of your system as closed, so no matter traverses, no mass traverses over into or out of the boundaries of your system. Or you could think of your system as isolated, and in that case, energy doesn't come in or out of your system. So the perfectly closed and isolated system, it's an idealization. It doesn't actually exist. It's kind of a theoretical, it's a helpful theoretical concept. But because if you had a perfectly closed and isolated system, you could never observe it or interact with it.
Got it.
Whereas you do want to, in a laboratory experiment, you want to build something that approximates a closed system, so you don't get interference, or an isolated system, so you don't have, there's no radiation that's interfering with your experiment. Okay, so you have approximately closed and isolated systems, but typically in nature we find open systems, which is the opposite of both of those. The thing with an open system, though, is that you could consider me an open system. And so I'm, slightly perspiring and I'm breathing. So this is, a mass going in and out. The lights are shining on me, and then I'm reflected. So I'm not isolated from the environment. If you think about systems in simpler terms, any system has to have available energy in order to move or to do work. Any given system, so that available energy to do work. So free energy, which is just a technical name for it. So the energy available to do work. That system can't give it to itself. That system has to be put into that state of having available free energy, and then that system can do work. The reason why that system can't give free energy to itself is, well, if you could do that, you could you could build, and we could construct such a system, or if it existed naturally, it would just keep going. It would never wear out. It wouldn't require any energy from the outside. So it'd be a perpetual motion machine. So to my mind, that shores up that first idea in the older argument, or I should say it's the contemporary way of expressing that first premise in the older argument, that everything in motion is put in motion by another. Right, so every system in motion is put in motion by another physical system that supplies it energy.
Right.
And so then you can weave into that the second idea that, well, if you compose the universe out of these systems, then you have that super system. It's still going to be of the kind that can't give itself the available energy to do work. So it won't be the sort of, it'll be this conjoint set of movers that won't suffice to explain why that whole thing is in motion, because each and any instance in the whole itself it's still insufficient to cause motion. So I think you can still put that argument in contemporary terms, in terms of systems, in terms of energy. I haven't read all of them by a long shot, but yeah, I'm sure there's something out there that's like, oh, well, it's going to be brains or strings or this kind of thing, and so this is where energy will come from. It's like, okay, well, but at least you're getting to, there's a kind of echo in the older argument. It's like, well, some versions of the first way in Aristotle, well, you get, or in the Aristotelian school, you get to this world soul. It's like, so it's not a physical mover, but it's a world soul. Okay, so it's something that's not, that's in some way independent of the cosmos of mobile things. But to my mind, that's at least a foothold that if you think of the material universe in this naturalistic way, that the material universe is entirely composed of systems that require energy to function, and they can't provide that energy to themselves without any reliance on something else, then eventually you can't say that the universe itself is the self-sustaining whole responsible for that if it's just composed out of all of these parts. So you're going to need to appeal to some supracosmic principle of some sort. So a mover, something that provides energy, that's not itself the sort of thing that needs something else to provide it energy. Fifth way, I might sketch out more briefly, because we've said already. We've already said a lot about how things are ordered and ordered to goals, and even ordered to goals at the level of the inorganic. Because Aquinas' fifth way focuses more on the non-living, right? It's that we observe in the world around us things that lack knowledge but still act regularly for the sake of something and obtain the best result, and it's not by chance that they do so. So we have the first premise is this observation that things that lack cognition are ordered to and attain ends in this good or best way. And attaining ends in this good or best way without knowledge is only possible if that order's been instilled in them or governed. If it's a governed order from the need to have an explanation for this order that the thing can't provide. The source of that teleology you claim is a mind. So many of the things that we've already talked about are similar to that. In the older cosmological model, one of the examples of that kind of action for the sake of a good is, so in non-cognitive inorganic elements or compounds, how they act in their environment. They have a certain mode of action or way of acting, and they're dependent upon a congenial environment to manifest that. And so it's not just that they can't give themselves their own natures. That's fine. But they also can't provide themselves with the environment in which to act and manifest what they're able to do. So that environment has to be able to receive what they're able to do. And so there's a kind of adjustment or fine-tuning at work, even in the older cosmological model for the fifth way, this argument from teleology. And so the sorts of things that we've talked about with symmetry or principles of conservation, or how different parts of the cosmos are adjusted to each other, and if you add in how these different parts throughout the history of the cosmos are arranged so as to make possible what will come into being at a later point in the history of the cosmos. So then you're looking at individually different substances that can't provide the context for their own order, but you're also looking at this whole intelligible space of options, right? This design of a natural history that unfolds over billions of years. And so the hallmark of an intellect is not just conceptualization and planning, but it's also conceptualization and planning that's independent. It doesn't depend upon where it is or when it is, and it can look out over the material possibilities and where things could exist in time. So it's this intellectual level of conceptualization is independent of being at a particular place or in a particular time, or thinking about things in particular places at particular times. And so if you have this order that no part of the universe can provide for itself because it's dependent upon what it can interact with, there you have this order to a good that's non-cognitive when you consider the things that are ordered, but because it's this sort of order that is cognitive, well, then you have to say, well, where's the mind that provided that order?
That makes perfect sense. So I'm hearing you say there's kind of two levels of teleology. There's the teleology of the bee. The bee has this efficient end stamped into its nature that it proceeds to. We're going to make these hexagon-shaped beehive for the sake of efficiency. So we have kind of like the granular teleology, but you're also saying there needs to be a teleology that would make a world in which the bee can come about.
And Aquinas gave both versions of the argument. Actually, I kind of combine them. So in different texts, he'll give they'll either give one or the other variant or focus on one or the other. Yeah, the more granular look at the level of the B versus let's think about if the cosmos were fire, could water survive? It's like no.
Mm-hmm. Last question, and I just want to thank you guys so much for your time. I hope we've provided a lot of answers for those who are curious about those fundamental laws, some of the natural philosophy that underpins our biology, our physics, our chemistry. But I also hope that we've opened doors to questions for people, that they can look into some of these topics that they're more interested in. My last question here is, so as Catholics, we believe there was a beginning in time to the universe. We've talked about the universe having a history, but I know there's rival ideas nowadays, something like a multiverse. Can we still hold to, from the scientific side, I know from Revelation we're always going to know for certain that it's true, that in the beginning God created, but just looking at contemporary cosmology, can we defend creation in time, or is it looking like something like a multiverse?
I think we don't know. And in the early days, Big Bang cosmology was looked at rather suspiciously. It's got this Catholic priest connected with it. Mm-hmm. It looks like it's pointing to something like creation. It was basically understood as creation science. You weren't allowed to teach it or study it in the Soviet Union. There's some evidence that other countries pursued a similar line, less formally. Mm-hmm. It's pretty hard to study Big Bang cosmology if you're a young professor, and your older professors basically say no. Mm-hmm. Okay, there's some evidence for that, but for the most part, I don't think that was the case. So in part, what the scientist or physicist or astronomer is faced with is they can trace the expansion of the universe back to their models to about 10 to the negative 34 seconds. Okay, so that's a lot, decimal point and a whole lot of zeros. And at that point, they run the two problems. They don't have a theory that brings together quantum mechanics and general relativity. And then they have this quantum mechanical indeterminism that's kind of a limitation. And there have been a lot of efforts to try to get behind that, to kind of solve those kinds of problems. And what they're faced with is an effect. Okay, the universe, its expansion, those earliest constituents were, for which they don't know the cause. And the cause does not seem to be any of the traditional causes known to science. Mm-hmm. So that's the perplexing kind of position that a scientist is in. And you do have theories, sort of like a range of theories that try to address this. The multiverse, the idea that we are just, what we call the universe, is just part of a much, much, much larger structure in which our universe had a beginning. Okay? Mm-hmm. And there are variations on that, including variations that really have just completely separate universes. It strikes me as pretty highly speculative. But before we get into that, I think it's important to talk about what we mean by creation. Creation is sometimes used very loosely, but actually has a very precise meaning. To say that something is created means to be the total cause of it, mm-hmm. total and complete cause of it, which means it's not going to be a motion or a kind of change, because in motion and change, we presuppose something that undergoes the change. Mm-hmm. Okay, and motion involves a state from which something is lacking that is later found in a state that it possesses some later time, mm-hmm. or maybe even vice versa. So that's not what creation ex nihilo means. Mm-hmm. Creation ex nihilo is ex nihilo precisely because there's no materials out of which it is made, because the creative act creates the materials itself. Okay? Got it. So there's no energy out of which creation happens, because mm-hmm. energy would be something that is a creation, would be created itself. Mm-hmm. So in that sense, it's not really a scientific question. Okay, it's not even really a natural philosophy question, mm-hmm. because we're talking about the cause of being out of nothing, and that's really going to be a metaphysical question and a theological kind of question. That's helpful. There are two broad, as far as I understand, Catholic traditions on this. There's a Catholic tradition that argues that you could not have had an infinite time preceding to now, okay? And that has a long history. It comes into the Catholic European medieval world through Christians in the Muslim countries and then through the development of Muslim countries. And that's still a widely held view among many Catholics now. Okay, so there's nothing heretical about it. Mm-hmm. Aquinas and many other thinkers faced this question because Aristotle thought the world was everlasting. I mean, it never had a beginning, and that was contrary to Catholic teaching. And what Aquinas argued was that creation means to be the total source and cause, like I said, but that could happen either with no beginning, because
right.
God from eternity just creates a universe with no beginning, mm-hmm. or God creates a universe with the beginning. Mm-hmm. He thought that both possibilities were rational. You could have either one of the two possibilities, and he didn't think that humanly we can tell.
Got it.
In other words, we know that God did it with a beginning of time because God has revealed it. Mm-hmm. That's how we know that. Mm-hmm. But that God did it with a beginning of time, we couldn't figure out on our own. Mm-hmm. So on his sort of thinking, the Big Bang would be, if it were the creation, you wouldn't be able to know. Mm-hmm. So the church has revealed that God created the universe ex nihilo with a beginning of time. It has not told us that the Big Bang is it.
Got it.
Okay.
Yeah.
And while it may look like it in a lot of ways, it's not like you can see it. Oh, there it was when there was nothing. When it was nothing, yeah. And now here it is. And the beginning itself is opaque to us.
Yeah, and that's a point worth emphasizing because Tom brought up some of the, just on the theoretical side, the limitations of tracking everything back to t equals 0. Mm-hmm. But there's also just observational limitations that telescopes or radio telescopes, whether they're ground-based or orbiting, they have limitations how far back they can, so how far away they can see, hence how far back in time they can see. Yeah. Mm-hmm. So there's that observational horizon, and that's, as technology improves, that gets pushed back. But then there's just according to the model side, there were not, if you get back early enough, there were not, there's not radiation that's free to travel. And so you're just not going to get detectable anything at a certain point. And I believe is that the 270,000, 300,000 year. It's several 100,000 years after the Big Bang event.
That you no longer have a hot glue. I mean, what?
It's called recombination for a weird reason, but it's where space becomes transparent to light. So
okay.
You can actually.
So you hit a point where space is no longer
transparent
to light.
Particle
and you can't
horizon.
see further back than that.
And even that, like there's the physics horizon of
these models. Right?
There's a certain, not physics in the theoretical, the horizon that if the universe has just our part of, just if there's a multiverse, just our part of the universe is if it's been expanding for a certain period of time globally, then there's just going to be a limit to how far any possible signal could possibly traverse to us at all. And typically the unobservable part of the universe is just beyond that physics horizon.
Okay, because of the traveling at the speed of light is just too far.
So there's not just theoretical, like we could solve the theoretical limitations, but there'd still be all of these empirical limitations.
I don't know that you're going to solve the quantum mechanical limitation, but that's
part 2.
But yeah.
Next time.
But there are scientists who say it's not just that it's going to take us a long time to figure this out, but we're never going to figure it out. All the evidence was destroying the event, or something like that. Okay, so, but then there have also been scientists who formulated a variety of I'll call them models or hypotheses that, like I said, try to see the Big Bang as occurring within a much larger structure that they call the multiverse. And a lot of that arises not just out of a desire to find a first cause or a first mover, but it also arises out of a desire to deal with something we could call fine-tuning. that there are lots of things in the universe that seem very precisely set, but the universe itself doesn't seem to explain why. And so the notion here would be that the multiverse generates billions of universes, and ours just randomly happens to have the features that it does that give rise to life and give rise to us. The idea is that there isn't any law of nature that says the Earth has to be located exactly where it is relative to the sun, around a sun-class star with all around a moon, with a moon like we have, all these features that make life possible here on Earth. But if you have enough stars, you're eventually going to have a roll of the dice that gives that. And so the logic by analogy is carried into, well, if you have enough universes and enough rolls of the dice, so to speak, you're eventually going to have one that looks like us. Now, I think what that does is really just push the whole question further back. And the example I want to use is the famous monkeys on a typewriter, okay, that if you give enough monkeys enough time on a typewriter, they'll eventually produce Hamlet just randomly, okay? But monkeys don't type, okay? I mean, they may do a little bit of this, but what they're going to do is they're going to pee and poop on the machine, and they're going to throw it, and all the other sorts of things that they do. It takes a really specially fine-tuned monkey.
And the monkey's fine-tuned already anyways, right? I mean,
on the typewriter, right.
Just the behavior.
So to generate a universe like ours by also generating a lot of random variations on other themes, that in itself requires a very special kind of multiverse that gives rise to that. So what you're really doing is kicking the problem back, and you're shoving it into a realm that's really, I'll be kind and say, there just doesn't seem to be a way to get much evidence, or there's not much evidence available, or the evidence is taken as, well, if we can't explain X, Y, and Z,
therefore there must be a
multiverse. So Steven Weinberg,
the
Steven Weinberg, who I referred to earlier, quotes Cardinal Schönborn in a paper, and he said Schönborn's exactly right. It's either God or the multiverse, except he's right about that, but he's wrong to come down on the side of God. You know there can't be a God, so there's got to be a multiverse.
Oh, that's a great.
But what the multiverse does is it presumes the contingency of what we call the universe. That it cannot explain itself.
Okay.
And that is really powerful.
That kicks in your third way, right?
Another
proof for God. Yeah.
And so when I put this together, Pope Pius, there's some very interesting stories about the Big Bang and Pius XII. And for the sake of time, I'll just mention the main point. One of the last things he did write on this subject, he talked about how the Big Bang was a way for the Christian to think about creation. So he held back in that address from saying the Big Bang is evidence of creation. And so I think the language of icon of creation is really apt, that it looks like, or it's an icon of the creation, because it's pointing to a kind of origin. It's an origin that remains uncertain and may be uncertain. And an Aquinas way of thinking, this is how creation with the beginning of time might look to us. It might look like an unknown, something we don't know and can't figure out. And so when you see the universe expanding, it's almost like you've got an ongoing kind of creation. The way I think of this, and I think the best way for a believer to think about this, is I don't want to let the atheist off the hot seat of coming up for a cause, okay? But I don't want to, on the other hand, say the Big Bang is creation. But I do want to say it's iconic for the creation. It's like God showing us what the creation looks like, or could look like. And so it gives us this kind of picture that helps us imagine it, think about it, believe in it, even in the uncertainty of we're not really quite sure what we're looking at here.
A final word for those listening to this. 2 questions for both of you to answer. The first is, what is your recommendation for an introductory book, course on these topics for someone who just wants to start at the very beginning And then what is something that you would recommend that you've written that for those at any level to take a look at some point in the future?
This is an area that's really developing, so it's hard for me to recommend. So on what I was calling the cliche about the position of the human in the universe, there's a guy named Dennis Danielson, who's a literature professor in Vancouver, who's published in the American Journal of Physics. And he's written a couple of good things on this, and he's, I think, the best I know on that particular topic.
Something from you too that people can read.
I read something called "The Heavens Declare the Glory of God."
You wrote this.
Yeah,
this. Okay.
And it shows up in a seminary journal, but it also could probably be found online.
I think what Tom is saying is true. It's hard to give recommendations because this, what's an introductory course in natural philosophy, just because usually it's, well, here's an introduction to metaphysics, or here's an introduction to the human person, and those, I mean, that's fine. But part of where we're coming from is the development of natural philosophy as an integral part of this overall speculative picture. That's been underdeveloped. So there's lots of old stuff I could mention. There's lots of stuff you could, like if you check out Ed Fazer's blog, he mentions lots of the old neo-scholastics that had manuals in what would have been called cosmology. But the difficulty there is that, I mean, they're working with 19th century science and developing 20th century science. I did write a very short introduction to natural philosophy for the Encyclopedia of Catholic Theology,
which I read, and I think it's fantastic.
Thanks. Yeah, so it's an article, and then there's also a short book form, and that the book form does have stuff that's not in the article, so you can get the book from ect.org. But that's really, even what I wrote there, that's really just an introductory level kind of brief survey of what this covers. If people really want to dig a bit more deeply into natural philosophy and the philosophy of science, I'd still recommend Father William Wallace's The Modeling of Nature, because that goes through a good bit of natural philosophy and then the philosophy of science. And then hopefully, in a year to 2 or 3, my own book on the philosophy of cosmology might be out. But I can't recommend that now.
Got it. Yeah, I look forward to reading it. Dr. Thomas McLaughlin, Dr. John Brungardt, thank you so much for your work in this area. There's a great poverty in taking our philosophical tradition and bringing it up to speed with the contemporary science. So I thank you for the work that you're doing, and thank you for being on Think Catholic.
Thank you very much.
Yeah, thanks for
having me. Good to see you, Austin. Thanks.